Every day, millions of cans of Spam roll off the production line, delivering the world's most famous canned meats to store shelves. But have you ever wondered how this iconic food is made at such a massive scale? Inside high-tech factories, raw ingredients are blended, cooked, and sealed into cans with incredible speed and precision. In this documentary, we take you behind the scenes of the Spam production process, from processing and packaging to distribution at an insane scale. The production of Spam canned meat in a factory is a complex process that combines traditional meat processing techniques with modern industrial methods to create one of the world's most iconic canned foods. Spam, originally developed by Hormel Foods in 1937, has become synonymous with convenience and durability, earning its place as a staple in kitchens worldwide. The journey from raw ingredients to the finished product involves several intricate steps, each meticulously controlled to ensure consistency, safety, and quality. It all begins with the procurement of high-quality pork and ham, which form the primary components of Spam. These meats are sourced from trusted suppliers who adhere to strict standards for animal welfare, hygiene, and sustainability. Upon arrival at the factory, the meat undergoes rigorous inspection to ensure it meets the required quality standards. Inspectors check for factors such as freshness, texture, color, and fat content, rejecting any batches that do not meet specifications. Approved meat is then stored in refrigerated units at precise temperatures to preserve its integrity until processing begins. Once inspected, the pork and ham are transported to the cutting and trimming area. Here, skilled workers or automated machinery trim the meat into uniform pieces, removing excess fat, sinew, and other undesirable parts. This step is crucial for ensuring consistent texture and appearance in the final product. The trimmed meat is then ground into fine particles using specialized grinders designed to achieve the desired consistency. The grinding process also helps to break down muscle fibers, making the meat more tender and easier to blend with other ingredients. After grinding, the meat mixture moves to the seasoning stage. A carefully formulated blend of salt, sugar, sodium nitrite, and spices is added to enhance flavor and preserve the meat. Sodium nitrite plays a critical role in preventing the growth of harmful bacteria, particularly Clostridium botulinum, while also contributing to the characteristic pink color of Spam. The exact spice mix varies depending on the type of Spam being produced, but common ingredients include garlic powder, paprika, and black pepper. These seasonings are measured with precision and mixed thoroughly into the meat to ensure even distribution. The next step is emulsification, where the seasoned meat mixture is transformed into a smooth, homogeneous paste. This is achieved using high-speed mixing equipment that incorporates air and water into the meat while breaking down fat globules into microscopic droplets. Emulsification is essential for creating the stable structure that gives Spam its signature texture. During this process, additional ingredients such as potato starch or carrageenan may be added to improve binding and stability. The emulsified mixture is continuously monitored to ensure it achieves the correct viscosity and consistency. Once emulsified, the meat mixture proceeds to the filling stage. In modern factories, automated filling machines dispense precise amounts of the mixture into pre-sterilized cans. These cans are typically made from tin-plated steel, which provides excellent resistance to corrosion and ensures long-term preservation of the contents. Each can is filled to a specific weight, ensuring uniformity across batches. After filling, the cans are sealed hermetically using double seam technology, creating an airtight barrier that prevents contamination and spoilage. The sealed cans then move to the retorting stage, where they are cooked under high pressure and temperature to ensure complete sterilization. Retorting is a critical step in Spam production, as it eliminates any remaining microorganisms and extends the shelf life of the product. After cooking, the cans are rapidly cooled to prevent overcooking and maintain optimal texture. Following retorting, the cans undergo a thorough inspection to verify their integrity. Visual checks ensure that the seals are intact and free from defects, while X-ray machines detect any foreign objects or abnormalities inside the cans. Any cans that fail these inspections are removed from the production line for further evaluation or disposal. Those that pass proceed to the labeling stage, where branding information, nutritional facts, and usage instructions are printed onto the cans. Labels also indicate the expiration date, which is calculated based on the expected shelf life of the product. Packaging represents the final stage of Spam production. Cans are grouped into cartons or crates, depending on the intended market, and prepared for distribution. Modern factories utilize automated packaging systems that efficiently organize and seal the containers, minimizing human error and maximizing throughput. Packaging materials are chosen for their durability and ability to protect the cans during transportation and storage. Additional protective layers, such as shrink wrap or pallet stretch film, may be applied to secure larger shipments. Quality control is woven into every aspect of Spam production, ensuring that each batch meets stringent standards for safety, taste, and appearance. Throughout the process, samples are regularly taken and analyzed to verify compliance with regulatory requirements. Microbiological tests confirm the absence of harmful bacteria, while chemical analyses measure parameters such as pH levels, moisture content, and nutrient composition. Sensory evaluations assess factors like flavor, aroma, and texture to ensure the product aligns with consumer expectations. Any deviations from established norms trigger immediate corrective actions, guaranteeing that only the highest quality Spam reaches the market. In addition to producing standard Spam, many factories specialize in creating variations tailored to specific tastes and dietary preferences. For example, reduced sodium or low-fat versions cater to health-conscious consumers, while specialty flavors like teriyaki or jalapeno appeal to those seeking bolder options. These variations require unique formulations and production techniques, showcasing the adaptability of modern manufacturing facilities. Some manufacturers also produce vegetarian or plant-based alternatives, expanding the range of choices available to diverse customer segments. Sustainability plays a significant role in contemporary Spam production. Factories increasingly focus on minimizing waste, conserving resources, and reducing environmental impact. Byproducts generated during processing, such as bone meal or rendered fat, are recycled into animal feed or biofuels, reducing landfill contributions. Water used in cleaning processes is treated before discharge to comply with ecological regulations. Energy-efficient equipment and renewable energy sources further contribute to greener operations. Moreover, sourcing ingredients responsibly, such as supporting local farmers who practice sustainable agriculture, aligns with growing consumer demand for ethically produced goods. Technological advancements continue to revolutionize the Spam industry. Automation streamlines production lines, enabling faster throughput while maintaining exceptional quality. Artificial intelligence and machine learning algorithms optimize processes by predicting equipment maintenance needs, identifying inefficiencies, and suggesting improvements. Robotics handle repetitive tasks with unmatched precision, freeing human workers to focus on higher value activities. These innovations not only boost productivity, but also allow factories to respond swiftly to changing market demands. Consumer trends heavily influence the evolution of Spam production. With increasing awareness about nutrition and wellness, there is a growing interest in healthier alternatives and transparent labeling. Manufacturers address these concerns by developing innovative formulations and providing detailed information about ingredient origins and production methods. Customization capabilities enable factories to produce niche products catering to regional preferences or emerging dietary fads, such as keto-friendly or gluten-free options. Global trade dynamics also shape the way Spam is manufactured. Export markets demand adherence to diverse regulatory frameworks, requiring factories to implement flexible systems capable of meeting varying international standards. Collaboration with suppliers, distributors, and retailers ensures alignment with global supply chains, facilitating timely delivery of products worldwide. Continuous investment in research and development keeps factories at the forefront of technological innovation, ensuring their competitiveness in an ever-evolving marketplace. Beyond the technical aspects of production, the cultural significance of Spam cannot be overlooked. In many regions, it is more than just a canned food. It is a symbol of resilience and adaptability. From wartime rations to modern culinary creations, Spam has proven its versatility time and again. Its widespread popularity has driven manufacturers to explore new applications and presentations, expanding its appeal beyond traditional boundaries. Today, Spam appears in everything from sandwiches and stir-fries to gourmet dishes and fusion cuisine, reflecting its enduring relevance in global gastronomy. Factories also prioritize food safety above all else, implementing comprehensive protocols to mitigate risks at every stage of production. Hazard analysis and critical control. Point systems identify potential hazards and establish measures to prevent them. Regular audits and certifications ensure compliance with local and international regulations. Employee training programs emphasize hygiene practices and proper handling procedures, reinforcing a culture of safety throughout the organization. Packaging design plays a vital role in the marketing and distribution of Spam. Modern factories invest heavily in developing attractive and functional packaging solutions that appeal to consumers while protecting the product. Innovations in material science have led to the creation of lightweight yet durable containers that reduce shipping costs and environmental impact. Resealable caps and ergonomic handles enhance user convenience, making it easier for customers to enjoy the product without compromising freshness. Supply chain management is another critical component of successful Spam production. Efficient logistics ensure a steady flow of raw materials into the factory and finished goods out to retailers. Strategic partnerships with suppliers help secure reliable sources of high-quality meat, while relationships with distributors facilitate rapid delivery to diverse markets. Real-time data analytics enable factories to forecast demand accurately, optimizing inventory levels and reducing waste. Research and development remain central to the growth of the Spam industry. Scientists and engineers continuously experiment with new formulations, processing techniques, and packaging technologies to improve product quality and sustainability. Emerging trends in biotechnology and fermentation offer promising avenues for enhancing flavor profiles and extending shelf life. Collaborations with academic institutions and research organizations provide valuable insights into cutting-edge developments that can be applied to commercial production. The economic impact of Spam production extends far beyond the factory floor. It supports jobs in agriculture, transportation, retail, and related industries, contributing significantly to local and national economies. By investing in community initiatives and sustainable practices, manufacturers demonstrate their commitment to corporate responsibility and long-term viability. Programs aimed at reducing carbon footprints, conserving water, and promoting biodiversity align with broader societal goals of environmental stewardship. As consumer preferences evolve, so too does the nature of Spam production. Health-conscious individuals seek products with fewer additives and artificial ingredients, driving manufacturers to adopt cleaner label approaches. Clear communication about ingredient sourcing and production methods builds trust and fosters loyalty among discerning customers. Educational campaigns highlighting the benefits of Spam as part of a balanced diet further reinforce its position as a staple in kitchens worldwide. Finally, the future of Spam production promises exciting possibilities. Advances in automation, digitalization, and artificial intelligence will likely transform traditional manufacturing processes, enabling greater efficiency and flexibility. Personalized nutrition platforms may one day allow consumers to customize their own Spam blends based on individual dietary needs and preferences. Meanwhile, ongoing efforts to reduce environmental impact and promote social responsibility will ensure that Spam remains a beloved and sustainable choice for generations to come. Through precise control of every stage, from meat procurement to final packaging, factories ensure that each can of Spam delivers consistent quality and satisfaction. This exploration reveals the depth and complexity behind the seemingly straightforward process of making Spam, highlighting the dedication and expertise required to bring this indispensable product to tables everywhere. The creation of canned tuna is a highly detailed and intricate process that combines centuries-old techniques with modern advancements in food science and technology. From the moment tuna is caught at sea to its final presentation on store shelves, each step demands precision, innovation, and an unwavering commitment to quality. The journey begins with the sourcing of high-quality fish. Tuna, known for its firm texture and rich flavor, is typically harvested using methods such as pole and line fishing or purse seining, which target specific species like skipjack, albacore, or yellowfin. Once captured, the fish are immediately processed aboard fishing vessels to preserve freshness. This involves gutting, cleaning, and chilling the tuna, ensuring it remains in optimal condition until it reaches the cannery. Modern fisheries prioritize sustainable practices, employing methods that avoid overfishing and minimize bycatch. Certifications from organizations like the Marine Stewardship Council provide assurance to consumers that the tuna comes from responsibly managed sources, appealing to eco-conscious buyers. Upon arrival at the factory, the tuna undergoes rigorous inspection. Skilled workers assess each fish for size, quality, and overall health, rejecting any specimens that do not meet strict standards. The selected tuna is then sorted by species and size before moving on to the next phase. After inspection, the tuna enters the pre-cooking stage, where it is cooked before being placed in cans. Pre-cooking helps remove moisture, break down connective tissues, and enhance the flaky texture of the tuna. This process also simplifies the removal of bones and skin, streamlining subsequent processing. The tuna is typically boiled or steamed under controlled conditions, ensuring uniformity in cooking while preserving its natural flavors and nutrients. Once pre-cooked, the tuna moves to the peeling and deboning stage. Traditionally performed manually, this task is now largely automated in modern factories. Advanced machinery gently strips away the outer layer of skin, while specialized equipment extracts the backbone and larger bones. Smaller bones may remain, but are often pulverized during later stages, contributing to the natural calcium content of the final product. After peeling and deboning, the tuna undergoes another round of inspection to ensure no remnants of bone or cartilage persist. The clean tuna is then portioned into uniform pieces, a task performed either by hand or through automated systems. These portions are transferred to stainless steel trays and prepared for canning. At this stage, some varieties of tuna may be lightly seasoned with salt or oil, depending on the desired flavor profile. For example, water-packed tuna retains a cleaner taste, while oil-packed versions offer richer mouthfeel and added calories. Specialty products might include herbs, spices, or sauces to create unique flavor combinations appealing to diverse palates. Canning itself is a meticulous operation requiring precision and timing. Portions of tuna are precisely weighed and loaded into pre-sterilized cans, which come in various sizes to accommodate different consumer needs. After filling, the cans are sealed hermetically using state-of-the-art sealing machines. A vacuum is often applied during sealing to minimize air trapped inside, further enhancing shelf stability and preventing oxidation. Once sealed, the cans proceed to the retort stage, where they are subjected to intense heat under pressure. Retorting is a critical step in the canning process, ensuring the complete destruction of harmful microorganisms, including spores of Clostridium botulinum. Temperatures exceeding 121 degrees Celsius are maintained for a specified duration, depending on the size of the can and the type of tuna being processed. This thermal treatment not only sterilizes the contents, but also locks in nutrients and flavors, allowing canned tuna to remain edible for years without refrigeration. After retorting, the cans are cooled rapidly to prevent overcooking and maintain optimal texture. Following cooling, the cans undergo another round of inspection for integrity, with particular attention paid to seal quality and can appearance. Any defective cans are removed from the production line, while those that pass inspection move on to labeling and packaging. Labels provide essential information about the product, including nutritional details, expiration dates, and preparation instructions. Packaging materials range from simple cardboard boxes for bulk shipments to eye-catching retail displays designed to catch consumers' attention on store shelves. Quality assurance permeates every aspect of canned tuna production. Throughout the process, samples are taken at regular intervals for thorough analysis. Microbiological tests confirm the absence of pathogens, while chemical analyses measure factors such as mercury levels, sodium content, and protein composition. Sensory evaluations assess texture, aroma, and taste to ensure consistency across batches. Any deviations from established standards trigger immediate corrective actions, guaranteeing that only the finest canned tuna reaches consumers. Beyond traditional white meat tuna, manufacturers produce a wide array of specialty products to cater to evolving consumer preferences. Light tuna, made from skipjack or yellowfin species, offers a milder flavor and lower fat content, appealing to health-conscious buyers. Albacore tuna, often labeled white meat, boasts a firmer texture and richer taste, favored by those seeking premium quality. Additionally, flavored varieties infused with lemon, garlic, or chili peppers add excitement to everyday meals, while eco-friendly options certified by organizations like the Marine Stewardship Council resonate with environmentally conscious shoppers. Sustainability has become a cornerstone of modern canned tuna production. Factories increasingly adopt practices aimed at reducing waste, conserving resources, and minimizing environmental impact. Byproducts such as fish heads and frames are repurposed into fish meal or pet food, while excess water used in processing is treated before discharge. Energy-efficient technologies such as solar panels and heat recovery systems help reduce carbon footprints. Moreover, partnerships with sustainable fisheries ensure that tuna stocks are managed responsibly, safeguarding marine ecosystems for future generations. Technological advancements continue to reshape the canned tuna industry. Automation enhances productivity by performing repetitive tasks with unmatched speed and accuracy. Robotic arms handle delicate operations like portioning and packing, while artificial intelligence optimizes workflows by predicting maintenance needs and identifying inefficiencies. Real-time data analytics enable precise tracking of inventory levels and market trends, facilitating better decision-making and responsiveness to consumer demands. Consumer trends play a pivotal role in shaping the evolution of canned tuna. With growing awareness about nutrition and wellness, there is increasing interest in products that align with healthy lifestyles. Manufacturers respond by developing low-sodium, high-protein formulations and providing transparent information about sourcing and production methods. Customizable options, such as pouches or ready-to-eat meals, cater to busy lifestyles, while organic and non-GMO labels appeal to discerning shoppers seeking purity and authenticity. Global trade dynamics influence how canned tuna is manufactured and distributed. Export markets require adherence to diverse regulatory frameworks, prompting factories to implement flexible systems capable of meeting varying international standards. Collaborations with suppliers, distributors, and retailers ensure seamless alignment with global supply chains, enabling timely delivery of products worldwide. Continuous investment in research and development keeps factories competitive, driving innovations in formulation, packaging, and sustainability. Cultural significance underscores the enduring appeal of canned tuna. Across continents, it serves as a symbol of convenience, adaptability, and nourishment. From quick sandwiches to elaborate salads, canned tuna seamlessly integrates into countless recipes, reflecting its versatility in culinary traditions. Its affordability and long shelf life make it particularly valuable in times of scarcity or crisis, cementing its role as a reliable staple in households around the globe. Factories prioritize food safety above all else, implementing comprehensive protocols to mitigate risks at every stage of production. Hazard analysis and critical control. Point systems identify potential hazards and establish preventive measures. Regular audits and certifications ensure compliance with local and international regulations. Employee training programs emphasize hygiene practices and proper handling procedures, fostering a culture of vigilance and responsibility throughout the organization. Packaging design plays a crucial role in marketing and distributing canned tuna. Modern factories invest in innovative solutions that balance functionality with aesthetics. Lightweight yet durable materials reduce shipping costs and environmental impact, while resealable lids and easy open features enhance user convenience. Eye-catching graphics and informative labels educate consumers about nutritional benefits, sustainability efforts, and preparation tips, strengthening brand loyalty and trust. Supply chain management ensures smooth logistics from ocean to table. Efficient coordination between fisheries, processors, and retailers guarantees a steady flow of raw materials and finished goods. Strategic partnerships with suppliers promote reliability and traceability, while real-time monitoring tools facilitate accurate forecasting and inventory control. These efforts minimize waste, optimize resource utilization, and enhance operational efficiency. Research and development drive progress in the canned tuna industry. Scientists explore new methods for improving flavor, texture, and nutritional value, while engineers refine processing technologies to maximize yield and reduce energy consumption. Innovations in biotechnology and fermentation hold promise for extending shelf life and enhancing microbial safety. Collaborations with academic institutions and industry experts foster knowledge exchange and accelerate the adoption of cutting-edge solutions. Economically, canned tuna production supports livelihoods across multiple sectors, from fishing communities to manufacturing plants and retail outlets. By investing in sustainable practices and community initiatives, manufacturers contribute to social welfare and environmental stewardship. Programs focused on reducing carbon emissions, conserving water, and promoting biodiversity reflect a broader commitment to corporate responsibility and long-term viability. As consumer preferences evolve, so too does the nature of canned tuna production. Health-conscious individuals seek minimally processed options free from artificial additives, driving demand for clean label products. Transparent communication about sourcing and production methods builds trust and fosters loyalty among informed customers. Educational campaigns highlighting the nutritional benefits of tuna as part of a balanced diet reinforce its position as a trusted dietary choice. Ultimately, the future of canned tuna production promises exciting possibilities. Advances in automation, digitalization, and artificial intelligence will transform traditional processes, enabling greater efficiency and flexibility. Personalized nutrition platforms may allow consumers to customize their own tuna blends based on individual dietary needs and preferences. Meanwhile, ongoing efforts to reduce environmental impact and promote ethical sourcing will ensure that canned tuna remains a beloved and sustainable option for generations to come. Through meticulous attention to detail at every stage, from catching the fish to sealing the can, factories ensure that each container of canned tuna delivers consistent quality and satisfaction. This exploration reveals the depth and complexity behind what appears to be a straightforward process, underscoring the dedication and expertise required to bring this indispensable product to tables everywhere. Each step in the process reflects not only technological advancement, but also a deep respect for tradition, sustainability, and consumer expectations, ensuring that canned tuna continues to thrive as a global staple. The production of beef jerky in a factory is a meticulous and highly controlled process that combines traditional curing methods with modern technology to create one of the most popular snack foods worldwide. From sourcing high-quality meat to packaging the final product, every step in this journey demands precision, innovation, and an unwavering commitment to quality. This detailed account delves deeply into the intricate processes involved in transforming raw beef into flavorful, long-lasting strips of jerky. It all begins with the procurement of premium-grade beef, typically sourced from trusted suppliers who adhere to strict standards for animal welfare, hygiene, and sustainability. The choice of cut plays a crucial role in determining the texture and flavor of the final product. Most factories use lean cuts, such as flank steak, sirloin tip, or round steak, due to their low fat content and tender yet firm texture. Upon arrival at the factory, the beef undergoes rigorous inspection to ensure it meets stringent quality criteria. Inspectors evaluate factors such as freshness, marbling, color, and overall condition, rejecting any pieces that do not meet specifications. Approved meat is then stored in refrigerated units at precise temperatures to preserve its integrity until processing begins. Once inspected, the beef moves to the trimming and slicing stage. Skilled workers or automated machinery carefully trim away excess fat, sinew, and connective tissues to achieve uniformity in size and shape. This step is critical for ensuring consistent cooking times and preventing undesirable textures in the finished product. The trimmed meat is then sliced into thin strips using specialized equipment designed to produce uniform thickness. Modern factories employ advanced slicers capable of adjusting blade angles and speeds to accommodate different recipes and preferences. These machines ensure accuracy while maintaining efficiency, enabling large-scale production without compromising quality. After slicing, the beef strips proceed to the marination phase, where they are infused with a carefully formulated blend of seasonings, spices, and preservatives. Marination is a cornerstone of beef jerky production, as it imparts flavor, enhances tenderness, and extends shelf life. Common ingredients include soy sauce, Worcestershire sauce, garlic powder, onion powder, black pepper, paprika, and brown sugar, among others. Some recipes may incorporate additional components like teriyaki glaze, chili peppers, or citrus zest to create unique flavor profiles catering to diverse consumer tastes. The marinade is prepared in large vats under controlled conditions to ensure consistency across batches. Once ready, the beef strips are submerged in the mixture for an extended period, typically ranging from several hours to overnight. During this time, the marinade penetrates the meat fibers, distributing flavors evenly and initiating the curing process. In some cases, vacuum tumbling may be employed to accelerate absorption by creating negative pressure that forces the marinade deeper into the tissue. This technique not only improves flavor infusion, but also helps retain moisture during subsequent drying stages. Following marination, the beef strips move to the dehydration stage, which is arguably the most defining step in beef jerky production. Dehydration removes moisture from the meat, concentrating its flavors and extending its shelf life while inhibiting microbial growth. Factories utilize industrial-grade ovens or dehydrators equipped with precise temperature and humidity controls to achieve optimal results. The ideal drying environment typically involves temperatures between 60 degrees Celsius and 75 degrees Celsius, depending on the desired texture and recipe requirements. During dehydration, The beef strips are arranged on racks or trays to allow even airflow around each piece. Continuous monitoring ensures uniform exposure to heat and prevents over-drying or burning. Depending on the thickness of the slices and the specific formulation, this process can last anywhere from 6 to 12 hours. As moisture evaporates, the meat shrinks and develops its characteristic chewy texture. Experienced operators regularly inspect the jerky throughout the drying cycle to assess doneness and make adjustments as needed. Once adequately dried, the beef jerky undergoes cooling and conditioning before proceeding to the next stage. Cooling allows residual heat to dissipate, stabilizing the product's internal temperature and preventing further shrinkage. Conditioning involves storing the cooled jerky in sealed containers for a short period to equalize moisture levels across individual pieces. This step ensures uniformity in texture and appearance, reducing the risk of cracking or breaking during packaging. With the jerky now fully prepared, it moves to the sorting and grading stage. Here, trained personnel visually inspect each strip for defects such as discoloration, uneven drying, or foreign objects. Any substandard pieces are removed from the production line, while those that pass inspection are sorted by size and quality grade. Sorting is essential for meeting customer expectations regarding consistency and presentation, particularly for retail products where aesthetics play a significant role in consumer appeal. The final step in beef jerky production is packaging, a critical phase that protects the product from external contaminants and preserves its freshness until consumption. Modern factories employ automated packaging systems capable of handling various formats, including vacuum-sealed bags, resealable pouches, or bulk containers. Packaging materials are chosen based on their ability to block light, oxygen, and moisture, which can degrade the jerky's quality over time. Common options include multi-layer plastic films with barrier properties or metallized coatings for enhanced protection. Labels provide important information about the product, including nutritional facts, ingredient lists, allergen warnings, and usage instructions. Many manufacturers also include QR codes or barcodes linking to digital content such as recipes, company history, or sustainability initiatives. For branded products, eye-catching graphics and branding elements enhance visual appeal, helping differentiate offerings in crowded marketplaces. Quality control permeates every aspect of beef jerky production, ensuring compliance with regulatory standards and consumer expectations. Throughout the process, samples are taken at regular intervals for thorough analysis. Microbiological tests confirm the absence of harmful bacteria, while chemical analyses measure parameters such as water activity, pH levels, and sodium content. Sensory evaluations assess texture, aroma, and taste to verify consistency across batches. Any deviations from established norms trigger immediate corrective actions, guaranteeing that only the highest quality jerky reaches consumers. Beyond standard formulations, many factories specialize in creating specialty varieties tailored to specific dietary preferences and lifestyle trends. Reduced sodium or no added sugar options cater to health-conscious buyers, while organic or grass-fed labels appeal to those seeking more sustainable choices. Gluten-free and keto-friendly formulations further expand the range of available options, reflecting growing demand for niche products. Additionally, flavored variations such as spicy habanero, smoky barbecue, or sweet teriyaki offer exciting alternatives for adventurous palates. Sustainability has become increasingly important in modern beef jerky production. Factories implement eco-friendly practices aimed at minimizing waste, conserving resources, and reducing environmental impact. Byproducts generated during processing, such as fat trimmings or bone fragments, are repurposed into animal feed, biofuels, or other useful applications. Water used in cleaning operations is treated before discharge to comply with ecological regulations. Energy-efficient technologies, such as solar panels or heat recovery systems, help lower carbon footprints. Moreover, partnerships with suppliers committed to ethical farming practices ensure responsible sourcing of raw materials. Technological advancements continue to revolutionize the beef jerky industry. Automation enhances productivity by performing repetitive tasks with unmatched speed and accuracy. Robotic arms handle delicate operations like slicing and packing, while artificial intelligence optimizes workflows by predicting maintenance needs and identifying inefficiencies. Real-time data analytics enable precise tracking of inventory levels and market trends, facilitating better decision-making and responsiveness to consumer demands. Consumer trends heavily influence the evolution of beef jerky production. With increasing awareness about nutrition and wellness, there is growing interest in products that align with healthy lifestyles. Manufacturers respond by developing formulations rich in protein, vitamins, and minerals, while minimizing additives and artificial ingredients. Transparent communication about sourcing and production methods builds trust and fosters loyalty among informed customers. Customizable options, such as personalized seasoning blends or portion-controlled packs, cater to diverse preferences and usage scenarios. Global trade dynamics shape how beef jerky is manufactured and distributed. Export markets require adherence to diverse regulatory frameworks, prompting factories to implement flexible systems capable of meeting varying international standards. Collaborations with suppliers, distributors, and retailers ensure seamless alignment with global supply chains, enabling timely delivery of products worldwide. Continuous investment in research and development keeps factories competitive, driving innovations in formulation, packaging, and sustainability. Cultural significance underscores the enduring appeal of beef jerky. Across continents, it serves as a symbol of convenience, adaptability, and nourishment. From trail snacks for outdoor enthusiasts to gourmet delicacies served at fine dining establishments, beef jerky seamlessly integrates into countless contexts, reflecting its versatility in culinary traditions. Its portability and long shelf life make it particularly valuable in situations requiring reliable sustenance, such as emergency preparedness or military rations. Factories prioritize food safety above all else, implementing comprehensive protocols to mitigate risks at every stage of production. Hazard analysis and critical control. Point systems identify potential hazards and establish preventive measures. Regular audits and certifications ensure compliance with local and international regulations. Employee training programs emphasize hygiene practices and proper handling procedures, fostering a culture of vigilance and responsibility throughout the organization. Packaging design plays a crucial role in marketing and distributing beef jerky. Modern factories invest in innovative solutions that balance functionality with aesthetics. Lightweight yet durable materials reduce shipping costs and environmental impact, while resealable closures and easy open features enhance user convenience. Eye-catching graphics and informative labels educate consumers about nutritional benefits, sustainability efforts, and preparation tips, strengthening brand loyalty and trust. Supply chain management ensures smooth logistics from farm to table. Efficient coordination between ranchers, processors, and retailers guarantees a steady flow of raw materials and finished goods. Strategic partnerships with suppliers promote reliability and traceability, while real-time monitoring tools facilitate accurate forecasting and inventory control. These efforts minimize waste, optimize resource utilization, and enhance operational efficiency. Research and development drive progress in the beef jerky industry. Scientists explore new methods for improving flavor, texture, and nutritional value, while engineers refine processing technologies to maximize yield and reduce energy consumption. Innovations in biotechnology and fermentation hold promise for extending shelf life and enhancing microbial safety. Collaborations with academic institutions and industry experts foster knowledge exchange and accelerate the adoption of cutting-edge solutions. Economically, beef jerky production supports livelihoods across multiple sectors, from livestock farming to manufacturing plants and retail outlets. By investing in sustainable practices and community initiatives, manufacturers contribute to social welfare and environmental stewardship. Programs focused on reducing carbon emissions, conserving water, and promoting biodiversity reflect a broader commitment to corporate responsibility and long-term viability. As consumer preferences evolve, so too does the nature of beef jerky production. Health-conscious individuals seek minimally processed options free from artificial additives, driving demand for clean label products. Transparent communication about sourcing and production methods builds trust and fosters loyalty among informed customers. Educational campaigns highlighting the nutritional benefits of beef jerky as part of a balanced diet reinforce its position as a trusted dietary choice. Ultimately, the future of beef jerky production promises exciting possibilities. Advances in automation, digitalization, and artificial intelligence will transform traditional processes, enabling greater efficiency and flexibility. Personalized nutrition platforms may allow consumers to customize their own jerky blends based on individual dietary needs and preferences. Meanwhile, ongoing efforts to reduce environmental impact and promote ethical sourcing will ensure that beef jerky remains a beloved and sustainable option for generations to come. Through meticulous attention to detail at every stage, from sourcing raw materials to sealing the final package, factories ensure that each piece of beef jerky delivers consistent quality and satisfaction. This exploration reveals the depth and complexity behind what appears to be a straightforward process, underscoring the dedication and expertise required to bring this indispensable product to tables everywhere. Each step in the process reflects not only technological advancement, but also a deep respect for tradition, sustainability, and consumer expectations, ensuring that beef jerky continues to thrive as a global favorite. The production of instant noodles in a factory is a fascinating blend of traditional culinary techniques and modern industrial processes. From humble beginnings as a convenience food in post-war Japan to becoming a global staple, instant noodles have evolved into one of the most widely consumed foods worldwide. The journey from raw ingredients to packaged noodles involves several intricate steps, each meticulously controlled to ensure consistency, flavor, and safety. It all begins with the procurement of high-quality wheat flour, which forms the foundation of instant noodles. Wheat flour is sourced from trusted suppliers who adhere to strict standards for gluten content, protein levels, and overall quality. Upon arrival at the factory, the flour undergoes rigorous inspection to ensure it meets these specifications. Inspectors evaluate factors such as moisture content, color, and texture, rejecting any batches that do not meet requirements. Approved flour is then stored in large silos under controlled conditions to preserve its integrity until processing begins. Once inspected, the wheat flour moves to the mixing stage, where it is combined with water, salt, and other additives to form dough. Some recipes may include additional ingredients such as eggs, milk powder, or vegetable oil to enhance flavor and texture. Modern factories use advanced mixing equipment capable of achieving uniform hydration and gluten development, ensuring consistent dough quality across batches. The mixing process typically lasts between 10 and 20 minutes, allowing the gluten network to develop sufficiently while maintaining pliability. After mixing, the dough proceeds to the sheeting stage, where it is flattened into thin layers using specialized rollers. These rollers are precision engineered to achieve uniform thickness, typically ranging from 1 to 3 millimeters, depending on the desired noodle type. The sheeted dough is then cut into long strips using rotary blades or laser cutting technology, creating the basic noodle shapes. At this stage, some manufacturers apply patterns or textures to the noodles, enhancing their visual appeal and improving sauce absorption during cooking. The freshly cut noodles move to the steaming phase, where they are partially cooked to set their structure and improve durability. Steaming involves exposing the noodles to hot steam for a controlled period, usually around 10 to 15 minutes. This step helps stabilize the gluten network, preventing excessive softening during subsequent frying or drying processes. Properly steamed noodles exhibit increased elasticity and resistance to breakage, qualities essential for producing high-quality instant noodles. Following steaming, the noodles enter the seasoning stage, where they are coated with a carefully formulated blend of oils, spices, and flavor enhancers. This seasoning mixture imparts the characteristic taste of instant noodles, while also acting as a preservative. Common ingredients include palm oil, monosodium glutamate, soy sauce, garlic powder, and chili flakes, among others. In premium varieties, natural extracts or freeze-dried vegetables may be added to enhance nutritional value and authenticity. The seasoning is applied evenly using spray nozzles or tumbling machines, ensuring consistent coverage on each noodle strand. For fried instant noodles, the next step involves deep frying the seasoned noodles in hot oil at temperatures between 140 degrees Celsius and 180 degrees Celsius. Frying removes excess moisture, reducing the noodle's water activity to levels that inhibit microbial growth and extend shelf life. During frying, the starch granules in the noodles gelatinize, creating a crispy texture when rehydrated later. Careful control of frying time and temperature ensures optimal crispness without overcooking or burning. After frying, the noodles are cooled rapidly to prevent residual heat from affecting their quality. Alternatively, non-fried instant noodles skip the frying step and instead proceed directly to dehydration. Dehydration is achieved using industrial-grade ovens equipped with precise temperature and humidity controls. The noodles are arranged on trays or conveyor belts and exposed to warm air currents for several hours, gradually removing moisture while preserving their structure. Air-dried noodles tend to retain more nutrients than their fried counterparts and offer a lighter texture upon rehydration. However, they often require longer cooking times and may lack the rich flavor imparted by frying. Once adequately dried, the noodles move to the sorting and packaging stage. Sorting involves inspecting the noodles for defects such as broken strands, uneven drying, or foreign objects. Automated systems equipped with cameras and sensors perform this task efficiently, identifying and removing substandard pieces before packaging. Sorted noodles are then portioned into individual servings and placed in pre-sterilized containers. These containers may take various forms, including plastic cups, bowls, or bags, depending on the intended market and usage scenario. Packaging materials are chosen based on their ability to protect the noodles from external contaminants and preserve freshness until consumption. Common options include multi-layer plastic films with barrier properties or metallized coatings for enhanced protection against light, oxygen, and moisture. For cup-style products, the container itself serves as both packaging and serving vessel, simplifying preparation and reducing waste. Labels provide important information about the product, including nutritional facts, ingredient lists, allergen warnings, and usage instructions. Many manufacturers also include QR codes or barcodes linking to digital content such as recipes, company history, or sustainability initiatives. Quality control permeates every aspect of instant noodle production, ensuring compliance with regulatory standards and consumer expectations. Throughout the process, samples are taken at regular intervals for thorough analysis. Microbiological tests confirm the absence of harmful bacteria, while chemical analyses measure parameters such as water activity, sodium content, and fat levels. Sensory evaluations assess texture, aroma, and taste to verify consistency across batches. Any deviations from established norms trigger immediate corrective actions, guaranteeing that only the highest quality instant noodles reach consumers. Beyond standard formulations, many factories specialize in creating specialty varieties tailored to specific dietary preferences and lifestyle trends. Reduced sodium or no added sugar options cater to health-conscious buyers, while organic or gluten-free labels appeal to those seeking more sustainable choices. Vegetarian and vegan formulations further expand the range of available options, reflecting growing demand for plant-based alternatives. Additionally, regional flavors such as spicy kimchi, coconut curry, or tom yum soup offer exciting alternatives for adventurous palates. Sustainability has become increasingly important in modern instant noodle production. Factories implement eco-friendly practices aimed at minimizing waste, conserving resources, and reducing environmental impact. Byproducts generated during processing, such as wheat bran or spent oil, are repurposed into animal feed, biofuels, or other useful applications. Water used in cleaning operations is treated before discharge to comply with ecological regulations. Energy-efficient technologies, such as solar panels or heat recovery systems, help lower carbon footprints. Moreover, partnerships with suppliers committed to ethical farming practices ensure responsible sourcing of raw materials. Technological advancements continue to revolutionize the instant noodle industry. Automation enhances productivity by performing repetitive tasks with unmatched speed and accuracy. Robotic arms handle delicate operations like cutting and packing, while artificial intelligence optimizes workflows by predicting maintenance needs and identifying inefficiencies. Real-time data analytics enable precise tracking of inventory levels and market trends, facilitating better decision-making and responsiveness to consumer demands. Consumer trends heavily influence the evolution of instant noodle production. With increasing awareness about nutrition and wellness, there is growing interest in products that align with healthy lifestyles. Manufacturers respond by developing formulations rich in fiber, vitamins, and minerals, while minimizing additives and artificial ingredients. Transparent communication about sourcing and production methods builds trust and fosters loyalty among informed customers. Customizable options, such as personalized seasoning blends or portion-controlled packs, cater to diverse preferences and usage scenarios. Global trade dynamics shape how instant noodles are manufactured and distributed. Export markets require adherence to diverse regulatory frameworks, prompting factories to implement flexible systems capable of meeting varying international standards. Collaborations with suppliers, distributors, and retailers ensure seamless alignment with global supply chains, enabling timely delivery of products worldwide. Continuous investment in research and development keeps factories competitive, driving innovations in formulation, packaging, and sustainability. Cultural significance underscores the enduring appeal of instant noodles. Across continents, they serve as a symbol of convenience, adaptability, and nourishment. From quick meals for busy professionals to comfort food enjoyed during travel or emergencies, instant noodles seamlessly integrate into countless contexts, reflecting their versatility in culinary traditions. Their affordability and long shelf life make them particularly valuable in situations requiring reliable sustenance, such as disaster relief efforts or military rations. Factories prioritize food safety above all else, implementing comprehensive protocols to mitigate risks at every stage of production. Hazard analysis and critical control. Point systems identify potential hazards and establish preventive measures. Regular audits and certifications ensure compliance with local and international regulations. Employee training programs emphasize hygiene practices and proper handling procedures, fostering a culture of vigilance and responsibility throughout the organization. Packaging design plays a crucial role in marketing and distributing instant noodles. Modern factories invest in innovative solutions that balance functionality with aesthetics. Lightweight yet durable materials reduce shipping costs and environmental impact, while resealable closures and easy open features enhance user convenience. From sourcing raw materials to sealing the final package, factories ensure that each serving of instant noodles delivers consistent quality and satisfaction. This exploration reveals the depth and complexity behind what appears to be a straightforward process, underscoring the dedication and expertise required to bring this indispensable product to tables everywhere. Each step in the process reflects not only technological advancement, but also a deep respect for tradition, sustainability, and consumer expectations, ensuring that instant noodles continue to thrive as a global favorite. Ever wondered how peanut butter goes from raw peanuts to the smooth spread in your jar? Inside massive factories, advanced machinery and precise processes work together to produce this beloved treat on an industrial scale. In this video, we break down every step of the peanut butter factory process that will leave you stunned. Get ready for a deep dive at how one of the world's favorite spreads is made. Firstly, that beast machine steps into the fields and starts shaking, loosening the peanuts from the roots and turning them inside out. After the plants are dug up, they're left to dry in the sun for a few days. Now the excess moisture is removed from the peanuts and they are ready to be picked up. Here come those bulky mechanical friends to do this job. Way much easier than it seems. It picks up the dried plants, separates the peanuts from other debris, and collects them in a hopper. From the last decade, China has been the largest producer of peanuts, and this strategic country usually makes a final count of around 20 million tons of peanuts every year. We have arrived at the facility where the entire peanut pile is fed into the cleaning setup. The unwanted stuff, like stones, twigs, and other foreign materials, is removed through pre-screening. This deshelling process is most satisfying when the machines delicately remove the outer shells of peanuts and reveal that beautiful, potential, and healthy nut we all were waiting for. Hang in there for a moment. They need to inspect manually for a quality check before they send the peanuts towards seed coating removing machines. Here, with gentle shaking, a lot of air pressure, and proper programming, that brownish skin is removed from the peanuts. The peanuts are treated with a medium boiling process to lock their texture and flavor and sanitize them by killing off any harmful bacteria or microorganisms by keeping the approximate boiling temperature near 121 stacking Quicks. However, it varies from company to company. As soon as the hopper is filled with the boiled peanuts, they are immediately packed and sealed in cans for distribution. These roasted peanuts are going to transform into something super buttery and delicious. Following a little roasting, the peanuts are cooled down to reach a temperature that is safe for handling and prevents them from becoming too hot or soggy during grinding. Those chosen peanuts take a trip towards this grinder and start revealing the smooth, buttery paste we all crave. It keeps grinding the peanuts until it reaches the desired smoothness, and the magic ingredients that will enhance the flavor keep being added little by little. This whirlwind of crushing and blending turns those nuts into pure deliciousness until its homogenization. This step is chaos that gives way to harmony. Through higher pressure, the peanut butter gains its final and smooth texture. Witness this final stage where the bottles are getting filled and sealed to secure the fresh peanut butter inside. Automated machines, like filling and cap sealing machines, work tirelessly, ensuring each jar is brimming with creamy goodness. Each jar gets dressed up, ready to impress on the supermarket shelf. Whether spread on toast, topped over ice cream, or simply enjoyed with a spoonful, chocolate peanut butter never fails to delight the senses. Chocolate peanut butter serves the taste buds with its rich, creamy texture and harmonious blend of sweet and nutty flavors. Look at those different patterns those machines are creating to give us that satisfying sight. It's more like a powerhouse of protein and other essentials for muscle repair and growth. It's delicious and satisfies your hunger between meals. Those roasted peanuts are ready for a delicious chocolate coating. This chocolate coating process requires precision to ensure each peanut is evenly coated. After coating, the peanuts are left to cool and harden. Once cooled, they are carefully packaged into food-grade safe containers for distribution and sale. Have you ever tried these? Honestly, I never have. If we talk about those chilled, delightful ice creams, you all know it's pretty popular around the globe. Every day in the United States, people consume around 50 million ice cream pints. That's enough to fill more than 9 Olympic-sized swimming pools. Whether it's a hot summer day or a chilly winter evening, Americans' love for this sweet treat stays strong all year round. And why wouldn't it? Just look at how creamy, rich, and delightful they are. Have you ever tried these Taiwanese crackers? They are pretty familiar and loved by many, from adults to children. In addition to their delicious taste and texture, Taiwanese crackers are also celebrated for their simplicity. Made from basic ingredients, they create a magical burst of flavors inside your mouth. Their straightforward approach allows the natural flavors to shine through, resulting in an authentic and satisfying snacking experience. These snacks come in a range of textures, from crispy and airy to dense and crunchy. In the last few years, there have been several conspiracies about their oil spraying, but I don't think it is a problem. Because if you dig deeper, snacking as a whole would be considered unhealthy. But after much time, a little snacking won't hurt. Do you agree? No doubt at least their production is pretty satisfying to watch. Check out the magical power of these automated systems for juice-filling sectors, where every drop counts, reducing electricity consumption. You will barely see more than a few workers working around because of the efficient automation. Talking about these bulky productions is my love language. I always fall for them. Do you? If it's a yes, we are the same, bro. So cheers to that. I want you to comment down below and let us all know whether you prefer bottled or fresh juices and why that is. Think you had a hard time scooping out the sweet and juicy flesh from the pineapple shell? I ruined 4 large pineapples just to bring out a nice pineapple ring. Didn't waste the rest though. Surprisingly, burger meat patties are low in carbs. A beef patty typically has none unless extras are added. These delicious burger patties are full of energy and nutrients, perfect for fueling your day in the most appealing ways you have ever imagined. Dried apricots are far healthier, sweet-dried fruits that can be enjoyed on their own as a satisfying snack or added to various dishes like salads, oatmeal, trail mix, or baked goods for a natural sweetness and nutritional boost. However, it's important to consume dried apricots in moderation due to their concentrated sugar content. Strawberries are delicious, sweet, and one of the most consumed fruits worldwide. But the question is, how can we have them fresh throughout the year? It has become more convenient since companies launched canned foods. This way, we can enjoy fresh strawberries all year round, even when they are not in season. Popping open a can and getting a burst of summer in every bite, either to top on your morning yogurt or blend into a smoothie, these beautiful fruits give you a lovely vibe. Honestly, these chickens are far more taken care of here, secure and cleaned, than in other local farms. Even in those large poultry facilities, they keep an eye on every chicken using robotic scanners, so they know every chicken is healthy, happy, and playing in advanced barns. Plus, did you notice those eggs systematically laying on the front row? That's how their automation works. It's all being observed and monitored until the eggs safely reach these units, where they will be tested for quality, etc. Here, the eggs automatically arrange for several inspections, like leak detection and cleaning purposes. Now comes this major egg inspector, which will approve only good eggs before they go into the disinfection chamber, to remove any microorganisms or pathogens. And lastly, they are ready to come your way. No matter how some people oppose the idea of bottled juices, soft drinks, or any other processed liquids having a limited time at breakfast, I fall for those bottled and tasty juices every time. We all know it's not a healthy activity. I mean, it hardly takes 10 to 15 minutes to extract fresh juice. Anyway, that's not just my problem. The majority of us choose convenience. I'm glad we made it out successfully, most importantly, together. And please take good care of yourselves. You are precious. If we need to make that yummiest jam, we probably should focus on the healthy growth of the fruits too. Now this matter is being set under a strict guide. But yeah, giving those pots the healthier and fluffy mud with the precise amount of materials. Now these robots start at the bottom by planting strawberry plants in containers or pouches. Water is essential, so they water each pot carefully to keep the strawberries happy and hydrated. When the strawberries grow big and red, it's time to pick them. For this purpose, this gigantic robot activates its clutches to delicately pick the ripened strawberries only. Since they're on different levels, it's easy to reach and pluck the delicious berries. This entire automation is so beautiful and satisfying. How these robots peculiarly pick up the strawberry from the stem and cut it without harming it. In botanical terms, berries have their seeds inside the flesh, but strawberry seeds are on the outside, so they didn't consider it in the berry list. Those fresh strawberries have arrived at their final destination, and here they will get even royal treatment. Just a little stop for a weight check. Once they make sure the demanded number of strawberries has arrived, they take them to the sorting units. And you better know what's going to be here with them. Of course, keeping you in mind, they're going to take that stack of strawberries for a manual check and make sure that only good quality strawberries are going further. Once they're sure of that, they let them pass on until they reach safe hands. Yep, these people are going to place each strawberry in that mold for the game-changing results. These robots automatically detect the green hull of a strawberry and beautifully just remove it without harming any other inch of the fruit. This is mind-blowing. Everything is under mechanical control. You can see how sharp eyes they have. Come on, they're doing this for you. Strawberries grow close to the ground, making them more susceptible to dirt, sand, and even tiny insects. The first wash, often a combination of water and little vibrations, removes these surface impurities. That's very important. But you know, fruits and veggies like these need another bath too. That's why they're given a second wash, often involving specialized sprays or misting with solutions like chlorine dioxide, which takes care of the tougher particles like pesticide residues and bacteria. This double trouble approach ensures the strawberries are as clean and safe as possible. They care about you. We care about you. See how honored we are to have you, just like these red, juicy strawberries. These fresh strawberries are now put into these containers. Yep, that's how you get the true and fresh flavor of frozen strawberries, because they are the same as, what to say, straight from farms to your plate. They are packed and firmly sealed to lock the pulpy fruit inside the food-grade containers. Just check out that large number of cans. Secondly, they use some of the frozen strawberries to make that glittery, yummy strawberry jam. All these frozen berries are put into the carriers to take them to the next stop, which is to load them into a container to add further ingredients. As the strawberries are loaded, now it's time to add further ingredients like sugar. They make sure the jam looks good, tastes good, and has the perfect texture, Once the handsome amount of sugar is poured, they need to control those figures and machines' capabilities by playing with some important buttons. The hot water tub is ready for these beautiful entities to enter and get bathed in the sweet syrup. What are they peeking at? Okay, the real drama has just begun. Once all the pulp comes to mix in that syrup, they put that material through sieves. This is important to give you that pulpless, smooth, jiggly jelly jam. Mixing, mixing, and more mixing. Everything is heated up in big pots or machines to make the strawberries blend and taste awesome. A special thing called pectin is added to make the jam just the right thickness. It's time to cook the material until it reaches its perfect texture, and that desired texture can be seen here. I think it's done. Yep, he's going to test the jam base to see if it's ready or needs to be cooked more. And yeah, it's good to go. Now the final process begins, to churn the mixture, to add a little more smoothness and to cool it side by side. A little now, it's like letting the flavors and texture settle and become best friends before they get packed into jars. And just wait, here we go. The whole warm jam base is ready. More close up here. It is, that creamy, smooth flow of my favorite jam. It's driving me crazy. Okay, time to pour that base and lock it in the jars. For that, these empty and starving bottles arrive. They are first neatly organized properly. The jam is carefully poured into jars all by itself. This process is usually automated in factories, with machines making sure each jar gets the right amount of fruity goodness. Here, we reach their sealing stage, where lots of lids are first picked in a proper style, beautifully conveyed to the roller coaster sort of belt, and finally to the sealing section where machines tightly seal the jars with lids. Okay, all those bottles are washed after being tightly sealed so that whatever sweetness remains on the outer side of the jars will be bathed away. We're now in the sticker section, where the robots will conveniently wrap stickers around these bottles so you will easily identify it's factory sealed. And of course, read that chart before eating anything. It's a good habit though. If you do, well, I don't. There's another technique too to add the labels one by one. All the bottles are labeled from whatever company they belong to and then piled up in the containers for the final bulk packaging. Bye-bye jam bottles. Don't forget my address and reach me soon. These mini jam bottles are filled up with the same freshness of fruit pulp and flavor to enrich your taste buds. Are those little nasty jam packets? You know, the ones at restaurants tucked next to the bread basket, bursting with fruity sunshine in one tiny bite. They're more than just sugar bombs. They might be tiny, but they're full of flavors to serve as starters for every meal. Also, these bite-sized marbles help stop food waste and make sure every spoonful is just right. These machines are the backbone of many industries, from food production to textile manufacturing to construction. With their robust blades and precise cutting mechanisms, they're built to tackle even the toughest materials. Imagine a scene where smoky aromas fill the air as meat sizzles on the grill, tantalizing taste buds with every flip and sear. Curious about the staggering output of flatbread producing machines in a single day? Prepare to be amazed. These efficient marvels can churn out an impressive number of flatbreads thanks to their high-speed capabilities and precision engineering. Depending on the size and capacity of the machine, production numbers can vary widely, ranging from thousands to even tens of thousands of flatbreads per day. Crafted with the finest ingredients and expert techniques, Our pastries are a symphony of flavors and textures. Meet chocolate depositors, the sweet secret behind every delectable treat. Hazelnuts are packed with nutrients like protein, healthy fats, fiber, and various vitamins and minerals. Not only do they promote heart health and aid in weight management, but they also support brain function and contribute to healthy skin and hair. These little blue gems are packed with antioxidants, which help fight off harmful molecules in our bodies and keep us feeling great. Motivate us to create more satisfying videos like these and smash the like button. These factories aren't just about quantity, they're about crafting quality too, ensuring that each slice of salami delivers a burst of savory perfection. Removing the skin helps trim down on excess fat and calories. You see, much of the fat in chicken resides in the skin. So by peeling it off, you're opting for a leaner, healthier option. Additionally, without the skin acting as a barrier, marinades and seasonings can penetrate the meat more effectively, enhancing flavor throughout. Talking about almonds, you must eat them daily so you can remember us and keep watching our videos. Cheese holds a special place on plates globally, with millions indulging in its creamy goodness daily. Hey, if you're enjoying this video, make sure you hit that like button so we'll know how many people are interested in watching our upcoming videos. The ancient Egyptians were one of the first civilizations to enjoy sweets, using honey as a primary sweetener. That minced meat, also known as ground meat, is incredibly versatile and used in a wide array of dishes worldwide. From savory meatballs to juicy burgers, its adaptability knows no bounds. It all boils down to freshness and food safety. Ideally, you want to consume tray-sealed meat within a few days of purchase to ensure peak freshness and flavor. Let's crunch into the world of factory-made delicious potato chips. From sourcing the finest potatoes to adhering to strict quality control standards, these factories ensure that each chip meets the crispy, satisfying standard you expect. These machines are the backbone of large-scale food operations, capable of handling a wide variety of produce with speed and accuracy. These factory-prepared meals undergo stringent quality control measures to ensure they meet safety and nutritional standards. From automated sorting systems that ensure only the highest quality ingredients make it onto the production line to state-of-the-art packaging machines that swiftly seal products for freshness, these machines are essential for meeting consumer demand while maintaining high standards. Each pepper is carefully inspected for size, color, and quality, ensuring only the best make it to market. Each juicy bite is a refreshing explosion of tangy sweet goodness, leaving taste buds dancing with delight. These innovative contraptions are designed to streamline the process of pouring batter with precision and consistency. These machines are the masters of precision, effortlessly dispensing just the right amount of batter, dough, or filling with each press of a button. That's where the multi-head weighing machine shines. Its multiple weigh heads work simultaneously to ensure accuracy and efficiency. Imagine effortlessly removing the outer layer of fruits and vegetables with precision and finesse. That's the magic of these machines. From potatoes to oranges, they strip away the tedious task of manual peeling, saving you time and labor costs. But it's not just about convenience, it's about consistency. With peeling machines, you get uniform results every time, ensuring your products look as good as they taste. Wait, before watching this clip, were you thinking peeling fruit is the hardest thing to do? I mean, it's messy, but not anymore. It's not just about indulgence, there are benefits too. Chocolate breads pack a double punch of flavor and nutrition. Bursting with tropical flavor and juiciness, mangoes are nature's candy that never disappoints. From automated temperature control to efficient oil filtration systems, they're designed to optimize performance and minimize waste. One of the most famous chocolate bars in the world is made at an unimaginable scale, with millions of KitKats rolling off the production line every single day. But how does a factory create the perfect balance of crispy wafer and smooth chocolate with such precision? Today, we'll take you inside the high-tech process of KitKat production, from mixing all the way to packaging. Get ready to uncover the incredible manufacturing behind one of the world's most beloved treats. The process begins with the careful selection and sourcing of raw ingredients. The primary components of KitKat bars include wheat flour, sugar, cocoa mass, cocoa butter, milk powder, vegetable oils, and emulsifiers. Nestlé, the brand behind KitKat, sources these ingredients from various regions worldwide, ensuring sustainability and adherence to strict quality standards. The cocoa used in KitKat is primarily sourced from the Nestlé Cocoa Plan, which promotes sustainable farming practices and fair trade. Once the raw materials arrive at the production facility, they undergo a series of inspections and tests to verify purity, consistency, and compliance with food safety regulations. This includes spectroscopic analysis for contaminants, moisture content testing, and sensory evaluations conducted by trained professionals. Once approved, the ingredients are stored in temperature-controlled silos and dispensing systems. The flour is kept in airtight storage to prevent contamination, while cocoa and milk powder are maintained under controlled humidity conditions to prevent clumping. Automated feeding systems transport these raw materials to the respective processing units, ensuring precise measurement and consistency in formulation. The first major step in KitKat production is wafer baking. The signature light and crispy wafer layers are created through a precise blending of wheat flour, water, sugar, and vegetable oils. Large industrial mixers, equipped with programmable logic controllers, ensure thorough mixing to produce a smooth and homogeneous batter. Once mixed, the batter is transferred via pressurized pumps to high-speed continuous wafer baking ovens. These ovens feature rotating baking plates that evenly distribute the batter across the surface, forming thin sheets of wafer. The baking plates operate at carefully controlled temperatures, typically around 180 to 200 degrees Celsius, ensuring uniform texture and color. The baked wafer sheets emerge golden brown and crisp, ready for the next stage. To enhance the crispness, the wafer sheets pass through a controlled cooling system. Conveyor belts transport the freshly baked wafers through a cooling tunnel, where calibrated fans gradually reduce the temperature to prevent thermal shock. The cooled wafers are then directed to the trimming and cutting station. Automated guillotine cutters trim the edges of the wafers to achieve uniform dimensions, ensuring consistency across all KitKat bars. Once trimmed, the wafers are transported to the layering station. Here, a fine layer of chocolate cream filling made from a precise blend of cocoa, sugar, and milk powder is evenly spread onto the wafers. Automated depositor machines ensure the filling is applied uniformly, maintaining the right thickness for optimal texture. The layering process continues with additional wafer sheets stacked on top, creating a multi-layered wafer slab. These slabs are then pressed under controlled pressure to bond the layers together without crushing the delicate structure. After layering, the wafer slabs proceed to the cutting stage. High-speed rotary or ultrasonic blade systems slice the large wafer sheets into precise rectangular portions, forming the individual KitKat fingers. Ultrasonic cutting technology is particularly effective in ensuring clean, precise cuts without generating excess crumbs or damaging the layers. The next crucial step is chocolate enrobing. The enrobing process begins with the preparation of molten milk chocolate, which is produced in large conching machines. These machines continuously grind and blend cocoa mass, cocoa butter, sugar, and milk powder, refining the mixture to achieve a smooth, velvety consistency. The conching process, which can last several hours, helps develop the rich, creamy texture and enhances the flavor profile of the chocolate. Once ready, the molten chocolate is fed into enrobing machines, where KitKat fingers pass through a curtain-like flow of chocolate. These enrobers ensure complete coverage, with excess chocolate removed using controlled air jets and vibrating conveyors. To achieve the signature glossy finish, the enrobed bars pass through a tempering unit, which carefully regulates the chocolate's crystallization process. This involves a precise cycle of heating, cooling, and reheating to stabilize the cocoa butter crystals, preventing bloom and ensuring a smooth, even texture. Following enrobing, the chocolate-covered KitKat bars enter a cooling tunnel. This tunnel, equipped with multi-zoned cooling technology, gradually reduces the temperature in stages to solidify the chocolate coating without causing cracks or condensation. The cooling process is carefully monitored using infrared sensors to maintain consistency. Once the chocolate is fully set, the KitKat bars move to the quality control and inspection stations. Advanced vision inspection systems, equipped with high-resolution cameras, scan each bar for defects, such as uneven coating, improper sizing, or misaligned layers. Bars that do not meet quality standards are automatically rejected by robotic sorting arms and sent for reprocessing. Additional quality checks include weight verification, moisture content analysis, and sensory testing conducted by trained specialists. After passing inspection, the KitKat bars are transported to high-speed wrapping machines. Individual bars are wrapped in foil or plastic film using heat-sealing technology, ensuring airtight packaging that preserves freshness. These wrapped bars are then grouped into multi-packs, which are subsequently boxed using robotic case packers. The packaging design is carefully printed with product details, barcodes, and branding elements before final sealing. The packaged KitKat bars are then palletized for distribution. Automated palletizing systems stack the boxes onto pallets in a precise arrangement to optimize space utilization during transportation. These pallets are shrink-wrapped for stability and loaded onto temperature-controlled trucks for delivery to distribution centers worldwide. The logistics process is carefully coordinated to ensure timely delivery, with real-time tracking systems monitoring shipments from factory to retailer. Throughout the entire production process, extensive quality control measures are in place to uphold product integrity. Each batch undergoes rigorous laboratory testing, including microbiological screening, allergen testing, and texture analysis. Data from all processing stages is logged in automated tracking systems, allowing full traceability and compliance with food safety regulations. While the fundamental principles of KitKat production remain consistent across different manufacturing plants, regional variations may exist to cater to local tastes and preferences. For example, KitKat flavors such as matcha green tea, strawberry, and sake are produced in Japan using specialized formulations. Some factories may also incorporate alternative chocolate blends, varying cocoa content to suit market demands. Nestlé continues to innovate and optimize KitKat production through advancements in automation, sustainability initiatives, and ingredient sourcing. Modern factories are increasingly utilizing AI-driven quality control systems, energy-efficient processing equipment, and eco-friendly packaging solutions to reduce environmental impact. With continuous improvements in manufacturing technology, KitKat remains a global favorite, offering consumers a consistently delightful chocolate experience in every bite. Mars bars, one of the most iconic chocolate confections in the world, are produced in highly sophisticated manufacturing facilities designed to ensure consistency, efficiency, and quality at every step of the process. The production of Mars bars involves multiple intricate stages, from sourcing and processing raw ingredients to forming, enrobing, cooling, and packaging the final product. Each step is meticulously controlled using advanced automation technology and stringent quality control measures to ensure the signature caramel, nougat, and chocolate combination is perfectly replicated in every bar. The process begins with the careful selection of raw ingredients. The main components of a Mars bar include sugar, cocoa mass, cocoa butter, skimmed milk powder, whey powder, palm fat, glucose syrup, lactose, milk fat, and egg whites. These ingredients are sourced from trusted suppliers and undergo rigorous quality assurance checks upon arrival at the factory. Sugar, which plays a crucial role in both the nougat and caramel layers, is stored in large silos, where it is kept dry and free from contamination. Cocoa products, including cocoa mass and cocoa butter, are stored in climate-controlled environments to prevent degradation. Dairy ingredients, such as skimmed milk powder and whey powder, are tested for purity and consistency before use. Once the raw ingredients are approved, the first major stage in Mars bar production is the creation of the nougat layer. Nougat is a key structural component of the bar, providing a soft, chewy texture that contrasts with the caramel and chocolate. The nougat making process begins in large industrial mixing tanks, where a combination of sugar, glucose syrup, and water is heated to create a syrup. This syrup is then aerated using a whipping system, which incorporates fine air bubbles to achieve the desired light and fluffy texture. During this stage, egg whites or hydrolyzed soy protein are added as stabilizers to maintain the nougat's consistency. Once the nougat mixture reaches the proper texture, it is transferred onto a continuous conveyor belt, where it is spread into an even layer. This belt passes through a cooling tunnel to allow the nougat to set before it reaches the next stage of the process. The cooled nougat layer is then precisely cut into rectangular strips using high-speed guillotine cutters. These strips will form the base of each Mars bar. The next step in the process is the caramel layer. The caramel used in Mars bars is created through a controlled cooking process that involves heating sugar, glucose syrup, and milk ingredients to high temperatures. This process requires careful monitoring to achieve the perfect balance of sweetness and viscosity. Industrial batch cookers equipped with automated temperature controls ensure that the caramel reaches the ideal consistency before it is deposited onto the nougat base. The caramel is applied as a continuous sheet over the nougat layer, ensuring even distribution and uniform thickness. Once the caramel is applied, the combined nougat and caramel layers proceed through a controlled cooling tunnel, where the temperature is gradually reduced to allow the caramel to set without becoming too hard or sticky. This ensures that the layers remain cohesive and easy to cut in the next stage of production. After cooling, the layered nougat and caramel sheets are fed into an automated cutting system, which uses precision blades to slice them into individual bar-sized portions. These freshly cut bars are then transported via conveyor belts to the enrobing station, where they receive their final chocolate coating. The enrobing process is a critical step in Mars bar production, as it gives the bars their signature smooth milk chocolate exterior. The chocolate coating is made from a blend of cocoa mass, cocoa butter, sugar, and milk powder, which is carefully tempered to achieve the perfect texture and glossy finish. The tempering process involves heating and cooling the chocolate in a controlled manner to ensure the cocoa butter crystals form a stable structure, preventing fat bloom and ensuring a smooth mouthfeel. At the enrobing station, the cut nougat and caramel bars pass through a curtain-like waterfall of molten chocolate, which fully coats them. Excess chocolate is removed using controlled air jets and vibrating conveyors to ensure an even layer without excessive buildup. Some factories use a two-stage enrobing process, where an initial thin layer of chocolate is applied as a base coat before the final, thicker chocolate layer is added. After enrobing, the chocolate-covered bars enter a multi-zone cooling tunnel, which gradually reduces their temperature in controlled stages. This cooling process allows the chocolate to set properly without developing cracks or a dull surface. The bars emerge from the cooling tunnel with a perfectly set chocolate shell, ready for the final stages of quality control and packaging. Quality control is a fundamental part of Mars bar production, ensuring that only bars meeting strict standards reach consumers. Automated vision inspection systems equipped with high-resolution cameras scan each bar for defects such as uneven coating, misshapen forms, or inconsistencies in size. Bars that do not meet the required specifications are automatically rejected and sent for reprocessing. Additional quality control measures include weight checks using precision weighing systems, texture analysis, and sensory evaluations conducted by trained specialists. Once the bars pass quality inspection, they proceed to the packaging area, where high-speed wrapping machines individually wrap each bar in foil or plastic film. These machines use heat sealing technology to create airtight packaging that preserves freshness and prevents contamination. The wrapped bars are then grouped into multi-packs and placed into branded cartons, which are sealed and labeled using automated case packing systems. The final step in the process is palletization and distribution. Automated palletizing systems stack the packaged bars onto pallets in a precise arrangement to optimize space utilization during transportation. The pallets are shrink-wrapped for stability and loaded onto temperature-controlled trucks for distribution to retail stores and supermarkets worldwide. The entire logistics process is carefully coordinated to ensure timely delivery while maintaining the product's freshness and quality. Throughout the entire manufacturing process, Mars maintains stringent quality control and food safety standards. Each production batch undergoes extensive laboratory testing, including microbial analysis, allergen testing, and moisture content verification. The company also invests in sustainable sourcing initiatives, ensuring that key ingredients such as cocoa and palm oil are responsibly sourced to minimize environmental impact. Different Mars manufacturing facilities may incorporate slight variations in processing techniques based on regional ingredient availability, consumer preferences, or proprietary formulations. Some facilities may use alternative chocolate blends with varying cocoa content to cater to specific markets, while others may modify the nougat formulation for textural differences. Additionally, Mars continuously invests in research and development to improve efficiency, reduce energy consumption, and enhance sustainability in its production processes. With advancements in automation, AI-driven quality control systems, and eco-friendly packaging innovations, the production of Mars bars continues to evolve while maintaining the signature taste and texture that consumers have loved for generations. Twix, one of the world's most beloved chocolate bars, is manufactured using a highly sophisticated and automated process that ensures each bar maintains its signature combination of crunchy biscuit, smooth caramel, and creamy milk chocolate coating. The production of Twix bars occurs in state-of-the-art factories that utilize precision engineering, cutting-edge food processing technology, and rigorous quality control protocols. From the sourcing of raw ingredients to packaging and distribution, every step is carefully orchestrated to guarantee consistency, efficiency, and superior taste. The process begins with the selection and procurement of high-quality raw materials. The key ingredients in Twix bars include wheat flour, sugar, palm oil, cocoa butter, skimmed milk powder, cocoa mass, lactose, whey powder, salt, and emulsifiers. These ingredients are sourced from carefully vetted suppliers who must meet strict food safety and sustainability requirements. For instance, the cocoa used in Twix bars is sourced through Mars' Cocoa for Generations initiative, ensuring ethical sourcing and environmental responsibility. Similarly, the palm oil used in the biscuits and caramel is certified sustainable to reduce environmental impact. Upon arrival at the manufacturing facility, the raw ingredients undergo thorough quality checks before entering the production process. These checks include spectroscopic analysis to detect contaminants, moisture content analysis to ensure freshness, and sensory evaluations to verify taste and aroma. Ingredients that meet the necessary standards are then stored in temperature-controlled silos and storage units to maintain their quality. The first step in the actual production process is the creation of the biscuit base. Twix bars are distinguished by their crunchy, shortbread-like biscuit layer, which requires precise preparation and baking. The process begins in large industrial mixers, where wheat flour, sugar, palm oil, and leavening agents are combined to form a dough. The mixing process is carefully timed to ensure the dough reaches the ideal consistency, firm enough to hold its shape during baking, yet tender enough to create the signature, crisp texture. Once the dough is fully mixed, it is transferred to an automated sheeting system. This system rolls the dough into a uniform sheet of the exact thickness required for Twix bars. The sheeted dough then moves to a rotary cutting machine, which stamps out individual biscuit fingers. Each biscuit is precisely cut to ensure uniform size and shape, allowing for seamless assembly in later stages. The cut dough pieces are placed onto conveyor belts and transported into a large industrial baking oven. These ovens operate using a continuous baking system, where the biscuit fingers travel through different heat zones that gradually bake them to perfection. The baking temperature is carefully controlled, typically ranging between 180 to 200 degrees Celsius, 356 to 392 degrees Fahrenheit, ensuring that each biscuit is evenly baked to a golden brown. Advanced infrared sensors monitor the biscuits throughout the baking process, ensuring uniformity in color, texture, and moisture content. Once fully baked, the biscuits pass through a cooling tunnel that gradually reduces their temperature, preventing cracking or breakage. Next, the caramel layer is prepared. The caramel used in Twix bars is made from a precise blend of sugar, glucose syrup, milk, and butter. This mixture is heated in large stainless steel batch cookers, where it undergoes controlled caramelization. The temperature and cooking time are crucial in achieving the perfect consistency, thick enough to stay in place on the biscuit, but soft enough to deliver a smooth, chewy texture. Once the caramel reaches the desired consistency, it is transferred to a continuous depositor system. This machine evenly dispenses a uniform layer of caramel onto each biscuit. The caramel application must be carefully controlled to ensure consistency in thickness across all bars. Any inconsistencies could lead to difficulties in chocolate enrobing or affect the final texture. With the caramel applied, the bars move along the conveyor belt to a cooling station, where they pass through a controlled cooling tunnel. This tunnel gradually reduces the temperature of the caramel, allowing it to set properly while maintaining its soft, chewy texture. After cooling, the caramel-coated biscuits are ready for the enrobing process, where they will be covered in rich milk chocolate. The enrobing process is one of the most critical steps in Twix production. The milk chocolate coating is prepared in large conching machines, which continuously grind and refine cocoa mass, cocoa butter, sugar, and milk powder. This process enhances the texture and flavor of the chocolate, ensuring a smooth, creamy consistency. The chocolate is then tempered, a controlled heating and cooling process that stabilizes the cocoa butter crystals. Proper tempering is essential to achieving the signature glossy finish and preventing fat bloom, white streaks that can appear on improperly tempered chocolate. At the enrobing station, the caramel-topped biscuits pass through a continuous chocolate waterfall. This ensures that each bar is fully coated in an even layer of chocolate. Any excess chocolate is removed using controlled air jets and vibrating conveyors, which help distribute the chocolate evenly without excessive buildup. Some factories employ a two-stage enrobing process, where a thin base coat of chocolate is applied first to ensure better adhesion before the final, thicker chocolate layer is added. Once the bars are coated, they enter a multi-zone cooling tunnel. This tunnel is divided into different temperature zones that gradually reduce the temperature, allowing the chocolate to set perfectly without cracking or becoming dull. The bars emerge from the cooling tunnel with a firm, glossy chocolate coating, ready for the next stage of production. Quality control is a top priority at every stage of Twix production. After cooling, the bars pass through a series of automated inspection systems. High-speed vision cameras scan each bar for inconsistencies in chocolate coating, caramel distribution, and overall shape. Any bars that do not meet specifications are automatically rejected and sent for reprocessing. In addition to visual inspections, quality control teams conduct random weight checks, moisture analysis, and sensory evaluations to ensure that each batch meets Mars's stringent quality standards. Once the bars have passed inspection, they move to the packaging stage. Twix bars are individually wrapped using high-speed horizontal flow wrapping machines. These machines use heat sealing technology to create airtight packaging that preserves freshness and prevents contamination. The wrapped bars are then grouped into multi-packs, which are sealed in branded cartons using automated case packing systems. After packaging, the final step in the process is palletization and distribution. Robotic palletizing systems stack the packaged bars onto pallets in precise arrangements, optimizing space for transport. The pallets are then shrink-wrapped for stability and loaded onto temperature-controlled trucks for distribution to retailers worldwide. Mars utilizes an advanced logistics network to ensure efficient delivery while maintaining product freshness. Throughout the entire production process, Mars adheres to strict food safety and sustainability standards. Each batch undergoes rigorous laboratory testing, including microbiological analysis, allergen testing, and texture verification. The company also invests in eco-friendly initiatives, such as reducing energy consumption in manufacturing and using recyclable packaging materials. Different Mars factories may employ slight variations in processing techniques based on regional ingredient availability and consumer preferences. For example, some regions may use alternative chocolate formulations with varying cocoa content, while others may adjust the caramel consistency based on market preferences. Additionally, limited edition Twix flavors, such as Twix white chocolate and Twix peanut butter, require modifications in ingredient formulation and processing techniques. As consumer demand for innovative flavors and healthier options grows, Mars continues to invest in research and development to improve Twix production. Recent advancements in AI-driven quality control, robotic automation, and sustainable ingredient sourcing are shaping the future of Twix manufacturing. Despite these innovations, the core principles of precision, consistency, and quality remain unchanged, ensuring that every Twix bar delivers the signature, crunchy, chewy, and chocolatey experience that consumers love. The making of a Hershey's chocolate bar is a complex, highly automated process that combines tradition with cutting-edge technology. From sourcing high-quality cocoa beans to wrapping the final product, every step is optimized for efficiency, consistency, and taste. The journey of a Hershey's bar begins with the careful selection of raw ingredients sourced from around the world. Cocoa, sugar, milk, and other ingredients are carefully tested to ensure they meet the company's high standards before they are transformed into the iconic chocolate bars that have been loved for generations. At the heart of every Hershey's chocolate bar is cocoa. The company sources its cocoa beans primarily from Ghana, Côte d'Ivoire, and Ecuador, regions known for producing high-quality beans with robust flavor profiles. Cocoa farmers in these areas harvest the ripe pods, extract the cocoa beans, and allow them to ferment for several days to develop their characteristic chocolatey taste. Once dried, the beans are shipped to Hershey's production facilities, where they undergo rigorous quality checks. Each shipment is tested for moisture content, flavor consistency, and the absence of contaminants. Only the highest quality beans make it through this stringent selection process. Once approved, the cocoa beans are sent to the roasting stage. Large industrial roasters expose the beans to carefully controlled heat, typically between 120 to 150 degrees Celsius, 248 to 302 degrees Fahrenheit, depending on the desired flavor profile. The roasting process is essential for developing the deep, complex flavors of chocolate. Different roasting profiles are used depending on whether the beans will be used for milk chocolate, dark chocolate, or other specialty products. After roasting, the cocoa beans enter the winnowing process. Specialized machinery cracks the roasted beans and removes the outer husks, leaving behind the valuable cocoa nibs. These nibs contain both the cocoa solids and cocoa butter needed for chocolate production. The nibs are then ground into a thick, dark paste known as chocolate liquor, which contains no alcohol despite its name. This chocolate liquor is the base for all Hershey's chocolate products. For Hershey's classic milk chocolate bars, chocolate liquor is combined with sugar, milk, and cocoa butter. The milk used in Hershey's chocolate is a key ingredient that gives it its distinctive taste. Unlike many European chocolates that use powdered or condensed milk, Hershey's uses fresh milk sourced from dairy farms in Pennsylvania and surrounding states. The milk is pasteurized and condensed before being blended with sugar to create a sweet, creamy base. The next stage in the process is refining. The chocolate mixture is run through a series of steel rollers that grind the particles to an ultra-fine consistency. This refining process is crucial for creating a smooth, melt-in-your-mouth texture. The finer the particles, the smoother the final chocolate will be. Once refined, the chocolate undergoes conching, a critical process that enhances flavor and texture. Conching machines, which resemble large industrial mixers, continuously stir the chocolate at controlled temperatures for several hours. This process aerates the chocolate, allowing unwanted acidic compounds to evaporate while enhancing its creamy mouthfeel. Hershey's uses a proprietary conching method that contributes to its signature flavor, which has a slightly tangy undertone due to controlled acidity in the milk. After conching, the chocolate moves to the tempering stage. Tempering is the process of heating and cooling chocolate in a precise manner to stabilize the cocoa butter crystals. Proper tempering ensures that Hershey's bars have a glossy finish, a firm snap, and a long shelf life. If the chocolate were not tempered correctly, it could develop fat bloom, a whitish streaking effect caused by unstable cocoa butter. Now, the tempered chocolate is ready for molding. Automated machines pour precise amounts of liquid chocolate into bar-shaped molds, which are then vibrated to remove air bubbles and ensure even distribution. The molds travel along a conveyor system into a cooling tunnel, where the chocolate solidifies into its final shape. Once cooled, the bars are ejected from their molds and transported via conveyor belts to the packaging area. Here, high-speed wrapping machines encase each bar in foil and branded paper sleeves, protecting the chocolate from moisture and light while ensuring a fresh, appealing presentation. Throughout the entire process, strict quality control measures are in place. High-resolution vision inspection systems scan each bar for defects, such as air bubbles, improper molding, or size inconsistencies. Bars that do not meet specifications are automatically rejected and sent for reprocessing. Additionally, random sensory evaluations are conducted by trained taste testers to ensure that the flavor, texture, and overall quality remain consistent. Once packaged, the final step is palletization and distribution. Automated robotic arms stack the packaged bars onto pallets, which are then shrink-wrapped for stability. These pallets are loaded onto temperature-controlled trucks and shipped to retailers worldwide. Hershey's operates an advanced logistics network that ensures timely delivery while maintaining product freshness. The entire manufacturing process is designed for efficiency, consistency, and sustainability. Hershey's continues to invest in eco-friendly initiatives, such as reducing water and energy consumption in production, using ethically sourced cocoa, and optimizing packaging materials to minimize waste. Different Hershey's factories may employ slight variations in processing techniques based on regional preferences and ingredient availability. Additionally, specialty products like Hershey's cookies and cream bars or Hershey's dark chocolate require modifications in ingredient formulation and processing times. As the chocolate industry continues to evolve, Hershey's remains at the forefront of innovation, combining tradition with advanced manufacturing techniques to produce its iconic chocolate bars. Through precision engineering, strict quality control, and a commitment to excellence, Hershey's ensures that every bar delivers the same beloved taste that generations have enjoyed. The making of Toblerone, the iconic triangular chocolate bar, is a masterclass in precision engineering, premium ingredient selection, and automated manufacturing processes. Unlike conventional chocolate bars, Toblerone stands out for its distinctive shape, rich Swiss milk chocolate, and the inclusion of honey and almond nougat. Every step, from sourcing the finest ingredients to molding the signature peaks, is meticulously controlled to ensure quality, consistency, and adherence to the Swiss chocolate making tradition. The process begins with sourcing high-quality ingredients. Toblerone's signature flavor comes from its carefully selected components: Swiss milk, sugar, cocoa mass, cocoa butter, honey, almonds, and egg whites. The milk, sourced from Swiss dairy farms, is a critical ingredient that contributes to the creamy texture. The cocoa is sourced from sustainable farms in Ghana and Ecuador, where beans are hand-harvested, fermented, and dried under strict quality control measures. Almonds are procured from select suppliers, ensuring they meet the required standards of size, flavor, and crunch. The honey, a key component that adds a subtle sweetness, is sourced from European beekeepers specializing in high-quality aromatic varieties. Once the ingredients arrive at the production facility, they undergo rigorous quality checks. Advanced spectroscopic analysis, moisture content testing, and flavor profiling ensure that each ingredient meets the brand's high standards. The cocoa beans are then roasted at carefully controlled temperatures to develop their deep, complex flavor. Different roasting profiles are used depending on whether the beans will be used for Toblerone's milk, dark, or white chocolate variations. After roasting, the cocoa beans move to the winnowing stage, where high-powered machinery cracks them open and removes the husks. The remaining cocoa nibs, which contain the essence of the chocolate, are then finely ground into a thick, rich paste known as chocolate liquor. This forms the base of Toblerone's chocolate. The chocolate liquor is blended with sugar, cocoa butter, and Swiss milk powder to create the signature smooth and creamy chocolate mixture. The next step in the process is refining. The chocolate mixture passes through a series of heavy-duty steel rollers that break down the particles to an ultra-fine consistency. This is crucial in achieving the signature melt-in-your-mouth texture. The refining process also helps blend the ingredients evenly, ensuring a perfectly smooth mixture. Following refining, the chocolate undergoes conching, a process that enhances its texture and flavor. Large conching machines continuously mix, aerate, and heat the chocolate for several hours, allowing volatile acids to evaporate and the flavors to develop fully. Toblerone's conching process is fine-tuned to create a silky texture and a well-rounded, rich taste. Meanwhile, the honey and almond nougat mixture is prepared in a separate area of the factory. Sugar, honey, and egg whites are heated and aerated to create a light, chewy nougat. Almonds, which have been roasted to bring out their nutty aroma, are chopped into small pieces and folded into the nougat mixture. The nougat is then cooled and ground into fine pieces before being incorporated into the chocolate. Once the chocolate has completed the conching process, the finely ground nougat mixture is carefully folded into it, ensuring even distribution. This step is crucial in maintaining the signature texture and taste of Toblerone. With the chocolate and nougat mixture fully blended, the next stage is tempering. Tempering is a precise process of heating and cooling chocolate in a controlled manner to stabilize the cocoa butter crystals. Proper tempering ensures that the chocolate has a glossy finish, a firm snap, and a smooth texture. Toblerone's tempering process is carefully calibrated to achieve the ideal consistency before molding. Molding is where Toblerone's iconic shape comes to life. The tempered chocolate is poured into custom-designed triangular molds that give the bar its distinctive peaks. The molds are gently vibrated to remove air bubbles and ensure even distribution of the chocolate. After molding, the bars pass through a cooling tunnel where they are gradually cooled to allow the chocolate to set perfectly without cracks or imperfections. Once solidified, the bars are removed from the molds and transported to the quality control station. Each bar is inspected using high-resolution vision cameras, which detect any inconsistencies in shape, texture, or coating. Automated sorting systems remove any defective bars, ensuring that only perfectly shaped Toblerone bars proceed to packaging. The packaging process is designed to maintain the freshness and integrity of the chocolate. Toblerone bars are individually wrapped in foil to protect them from moisture and light, then placed into the iconic triangular cardboard cartons. High-speed packaging machines fold and seal the cartons with precision, ensuring that the bars remain securely enclosed. Following packaging, the bars are palletized using robotic systems, stacked carefully for stability during transport. These pallets are shrink-wrapped and loaded onto trucks for distribution to markets around the world. temperature-controlled logistics ensure that the chocolate remains in perfect condition during transit. Throughout the entire manufacturing process, Toblerone maintains strict quality control measures. Each batch undergoes laboratory testing, including texture analysis, microbial screening, and taste assessments conducted by trained specialists. Data is continuously logged in automated tracking systems, allowing for full traceability of every Toblerone bar produced. Different Toblerone manufacturing facilities may employ slight variations in processing techniques depending on regional ingredient availability and market preferences. Specialty additions, such as Toblerone white chocolate or Toblerone dark, require slight modifications in ingredient formulations and processing steps. As consumer preferences evolve, Toblerone continues to innovate while maintaining the brand's heritage of Swiss chocolate craftsmanship. Investments in sustainable cocoa sourcing, eco-friendly packaging solutions, and advanced automation ensure that Toblerone remains a global favorite while reducing its environmental footprint. Through precision engineering, time-honored techniques, and a commitment to quality, every Toblerone bar delivers the signature taste and texture that chocolate lovers around the world cherish. The production of Snickers, one of the world's most popular chocolate bars, is a highly automated and meticulously controlled process designed for efficiency, consistency, and large-scale output. With its signature combination of nougat, caramel, peanuts, and milk chocolate, Snickers is produced in state-of-the-art facilities that use cutting-edge food processing technology, ensuring that every bar meets the brand's high-quality standards. From sourcing the finest raw ingredients to packaging and distribution, every step is optimized to deliver the same taste, texture, and satisfaction in every bite. The journey of a Snickers bar begins with the careful selection of raw materials. The main components include sugar, peanuts, milk powder, cocoa mass, cocoa butter, palm oil, glucose syrup, egg whites, and emulsifiers. These ingredients are sourced from carefully vetted suppliers, ensuring compliance with strict food safety and sustainability standards. Mars, the company behind Snickers, prioritizes responsible ingredient sourcing, ensuring that cocoa is ethically obtained through its Cocoa for Generations program, which promotes fair labor practices and sustainable farming methods. Peanuts, another crucial ingredient, are primarily sourced from the United States, where they are grown under controlled conditions to maintain size, flavor, and crunch. Once the ingredients arrive at the manufacturing facility, they undergo a rigorous quality control process. Each batch is tested for moisture content, purity, and potential contaminants. Peanuts, in particular, go through an additional inspection phase, where they are sorted by size and quality. High-speed optical sorting machines remove any defective or discolored peanuts, ensuring that only the best nuts make it into Snickers bars. The first major step in the Snickers production process is creating the nougat base. Nougat provides the chewy texture that forms the foundation of the bar. It is made by combining sugar, corn syrup, and water, which are heated in large industrial cooking vats to create a syrup. This syrup is then aerated using high-powered whipping machines, which incorporate fine air bubbles, giving the nougat its characteristic light and chewy texture. Egg whites or soy protein are added as stabilizers to help maintain consistency. Once aerated, the nougat is spread onto a moving conveyor belt in a continuous sheet, where it is allowed to cool and set. This process is carefully controlled to prevent the nougat from becoming too hard or too soft. Automated guillotine cutters then slice the nougat sheet into uniform rectangular portions, ensuring that each piece is the exact size required for Snickers bars. Next comes the caramel layer. The caramel in Snickers is made from a blend of sugar, glucose syrup, milk, and butter, which is heated in large stainless steel batch cookers. The temperature is carefully monitored to achieve the perfect viscosity, thick enough to hold its shape, but soft enough to provide a smooth, chewy texture. Once cooked to perfection, the caramel is poured in a controlled stream onto the nougat base. The caramel-covered nougat passes through a cooling tunnel, where it sets just enough to be firm, but still pliable. Now it's time to add the peanuts. Before being incorporated into the bars, the peanuts are roasted in industrial ovens to enhance their flavor and crunch. After roasting, they are cooled and evenly distributed over the caramel layer using precision peanut dispensers. These machines ensure that each bar receives the right amount of peanuts, maintaining uniformity across all Snickers bars. Once the peanuts are in place, the layered nougat, caramel, and peanut sheet moves to the cutting stage. High-speed rotary blades slice the continuous sheet into individual bar-sized portions. Each cut must be precise, ensuring that the caramel and nougat layers remain intact while maintaining a consistent size. The next critical step is chocolate enrobing. The milk chocolate coating used for Snickers bars is made from a blend of cocoa mass, cocoa butter, sugar, and milk powder. This mixture is refined and conched in large machines that continuously grind the chocolate to achieve a smooth texture. The chocolate is then tempered, a process that involves controlled heating and cooling to stabilize the cocoa butter crystals. Proper tempering ensures a glossy finish and prevents fat bloom, which can cause chocolate to develop a dull appearance. At the enrobing station, the cut bars pass through a waterfall of liquid milk chocolate, fully coating them. Excess chocolate is removed using controlled air jets and vibrating conveyors, ensuring an even layer without excessive buildup. Some factories use a two-stage enrobing process, where a thin base coat of chocolate is applied first to create a stable foundation before the final. Thicker chocolate layer is added. After enrobing, the bars enter a multi-zone cooling tunnel. This tunnel gradually lowers the temperature in controlled stages, allowing the chocolate to set properly without developing cracks or dull spots. Once fully cooled, the Snickers bars emerge with a perfectly solidified chocolate coating, ready for quality inspection. Quality control is a critical component of Snickers production. Each bar undergoes a series of automated inspections to ensure that it meets strict specifications. High-speed vision inspection systems equipped with high-resolution cameras scan each bar for defects such as uneven coating, improper size, or misshapen layers. Any bars that do not meet the required standards are automatically rejected and sent for reprocessing. Additional quality checks include weight verification, moisture content analysis, and sensory testing conducted by trained specialists. Once the bars have passed inspection, they move to the packaging stage. Snickers bars are individually wrapped in plastic film using high-speed horizontal flow wrapping machines. These machines use heat sealing technology to create airtight packaging that preserves freshness and prevents contamination. The wrapped bars are then grouped into multi-packs and packed into branded cartons using automated case packers. The final step in the process is palletization and distribution. Automated systems stack the packaged cartons onto pallets in precise formations, optimizing space for transport. These pallets are then shrink-wrapped for stability and loaded onto temperature-controlled trucks for distribution to retailers worldwide. Snickers bars are shipped to over 70 countries, requiring an advanced logistics network to ensure that they arrive fresh and in perfect condition. Throughout the entire production process, Mars maintains stringent food safety and sustainability practices. Each batch undergoes extensive laboratory testing, including microbiological screening, allergen testing, and texture verification. The company also invests in sustainable ingredient sourcing, reducing its environmental footprint through energy-efficient manufacturing processes and eco-friendly packaging solutions. Different Snickers manufacturing facilities may employ slight variations in processing techniques based on regional, ingredient availability, and consumer preferences. For example, some regions may use alternative chocolate blends with varying cocoa content, while others may modify the nougat or caramel consistency based on market demands. Additionally, special edition Snickers bars, such as Snickers almond or Snickers peanut butter, require modifications in ingredient formulation and production methods. As consumer preferences evolve, Mars continues to innovate while maintaining the classic Snickers taste and texture. Advancements in automation, AI-driven quality control, and sustainable manufacturing practices are shaping the future of Snickers production. Despite these innovations, the fundamental principles of precision, consistency, and quality remain unchanged, ensuring that every Snickers bar delivers the same delicious combination of chewy nougat, gooey caramel, crunchy peanuts, and smooth milk chocolate that has made it a favorite among chocolate lovers worldwide. The production of Tony's Chocolonely chocolate bars is a carefully designed process that emphasizes ethical sourcing, sustainability, and high-quality chocolate-making techniques. Unlike traditional chocolate brands, Tony's Chocolonely is dedicated to creating a slave-free chocolate industry, ensuring that every step in the supply chain is transparent and fair. From sourcing cocoa beans from cooperatives in West Africa to molding and packaging the final bars, the production process is a seamless blend of traditional craftsmanship and modern automation. The journey of a Tony's Chocolonely bar begins with cocoa sourcing. The company partners with cooperatives in Ghana and Côte d'Ivoire, regions that are known for cocoa production, but also face significant challenges related to child labor and unfair wages. Tony's Chocolonely implements direct trade practices, paying a premium for cocoa and providing additional support to farmers through training programs and financial resources. This ensures that the beans are ethically sourced while maintaining a high standard of quality. Once harvested, the cocoa beans go through a meticulous post-harvest process. Farmers ferment the beans for several days, a crucial step that develops the deep, complex flavors needed for premium chocolate. After fermentation, the beans are spread out under the sun to dry, reducing moisture content and preventing mold growth. When dried to the appropriate level, the beans are packed into jute sacks and shipped to Tony's Chocolonely's processing facilities. Upon arrival at the factory, the beans undergo rigorous quality control checks. Samples from each shipment are tested for moisture levels, flavor consistency, and potential contaminants. Beans that pass inspection are stored in climate-controlled silos to maintain freshness before entering the production line. The first step in the chocolate making process is roasting. Large industrial roasting machines heat the beans at precise temperatures, usually between 120 to 150 degrees Celsius, 248 to 302 degrees Fahrenheit. This process enhances the natural chocolate flavors and eliminates unwanted bitterness. The roasting time and temperature depend on the type of chocolate being produced. Dark chocolate requires a slightly longer roasting process than milk chocolate to develop its rich, bold flavors. Once roasted, the beans enter the winnowing process. A specialized machine cracks open the roasted beans and removes the outer husks, leaving behind the valuable cocoa nibs. These nibs contain both cocoa solids and cocoa butter, the essential components of chocolate. The nibs are then ground into a thick, smooth paste known as chocolate liquor. This process, carried out by industrial grinders, reduces the particle size of the nibs, creating a velvety consistency. At this stage, different chocolate variations begin to take shape. For Tony's Chocolonely's milk chocolate bars, the chocolate liquor is combined with sugar, milk powder, and additional cocoa butter to create a creamy texture. For dark chocolate, higher cocoa percentages are used with less sugar and no milk. The next step in the process is refining. The chocolate mixture is passed through heavy-duty steel rollers that grind the ingredients into ultra-fine particles. This step is crucial for achieving the smooth texture that defines high-quality chocolate. The finer the particles, the better the melt-in-your-mouth experience. Following refining, the chocolate undergoes conching, a process that enhances both texture and flavor. Large conching machines continuously mix and aerate the chocolate for several hours, allowing any residual acidity to evaporate while intensifying the chocolate's richness. The conching time varies depending on the desired flavor profile. Longer conching results in a smoother, more developed taste. After conching, the chocolate is tempered, a precise heating and cooling process that stabilizes the cocoa butter crystals. Proper tempering ensures that Tony's Chocolonely bars have a glossy finish, a satisfying snap when broken, and a long shelf life without developing fat bloom, the white streaks that can appear on improperly tempered chocolate. Once tempered, the liquid chocolate is ready for molding. Unlike most chocolate bars, Tony's Chocolonely bars are intentionally molded in an uneven pattern, symbolizing the unequal distribution of wealth in the chocolate industry. Automated machines pour precise amounts of chocolate into these custom-designed molds, which are then gently vibrated to remove air bubbles and ensure even distribution. The molds are then transferred to a cooling tunnel, where the chocolate gradually solidifies under controlled temperatures. This process prevents the bars from developing surface defects and ensures that they retain their perfect shape. Once the chocolate has fully set, the bars are ejected from the molds and sent to the quality control station. High-speed vision inspection systems scan each bar for defects, such as air bubbles, improper molding, or uneven texture. Any bars that do not meet the required standards are removed from the production line and either reprocessed or discarded. After passing quality checks, the bars move to the packaging stage. Tony's Chocolonely uses brightly colored, easily recognizable wrappers, each featuring bold typography and branding. The packaging process is fully automated, with high-speed wrapping machines, sealing each bar in foil and paper to protect it from moisture and contamination. The wrapped bars are then packed into cartons using robotic case packers. The final step in the process is palletization and distribution. Automated robotic systems stack the packaged bars onto pallets in a precise arrangement, optimizing space for transport. The journey begins with picking the perfect potatoes. But not just any potatoes will do. McDonald's chooses only russet Burbank potatoes for their fries. These aren't your average spuds. They're chosen for their unique qualities, making them perfect for frying. These potatoes aren't picked just because they taste good. They're also chosen because they can keep the proper quality and texture even when made in big batches for fast food. Take the United States, for instance, where russet Burbank potatoes are a top pick, and most McDonald's contractors are from the US. Here, you can see how the potatoes are dug up from the ground with the help of heavy-duty, all-in-one machines. Inside these machines, advanced tools clean the potatoes, removing all the dirt. This process continues until all the potatoes are gathered. All these potatoes are then collected and stored in a room. This way, they can be quickly taken out when needed, ensuring that the processing never stops. You'd be amazed by the sheer quantity of potatoes here. Believe it or not a single potato goes bad. They're all used up within 15 days. A big reason for this is that McDonald's makes approximately 9 million pounds of French fries every day. As soon as these potatoes are taken to the factory as needed, that's when the real magic begins. Let's take you inside the factory, where you'll see French fries being made. First up, we've reached the potato washing station. Here, the potatoes are tossed into cleaning containers filled with water. Thanks to vibrating belts, the fast-flowing water easily washes away the dirt from the potatoes. After a thorough wash, a portion control elevator lifts the potatoes out of the water and transfers them to another belt. This belt gradually collects the potatoes in a container-like hose, sending small batches to the peeling machines for further washing. The peeling process is incredibly delicate. ensuring only the skin is removed without wasting any part of the potato. Once the potatoes are peeled and clean, they're moved through belts to the third washing chamber. Here, the final wash takes place with water containing chlorine and safe chemicals. Freshly washed and ready, these potatoes are then taken by the belts for special treatments. What you're seeing, all these units standing tall, are actually fine cutting chambers. They expertly cut the peeled potatoes into uniform sizes. This is why McDonald's fries always look the same in shape and length. Their machines work in a precise and effective way. The machines propel the potatoes at speeds of 60 to 70 mph through high-pressure water knives. These water knives finely slice the potatoes into thin strips, which are then sorted by their size and shape. After being cut, the fries are washed again and then placed on an automatic elevator, taking them toward the boiler for the next step in their journey to becoming perfect fries. Sometimes the cut fries get special treatment with a mix of sugar and sodium acid pyrophosphate for two main reasons. The sugar helps the fries achieve that perfect golden brown color when fried, while the sodium acid pyrophosphate keeps the fries from turning grey or brown, whether they're cooked or frozen. The real reason they're boiled for a bit is to make the inside of the fries soft, so when they're fried later, they turn out crispy on the outside but remain soft inside. The fries head straight to the boiler. Here, any broken or misshapen fries stick to the belts, while the perfectly shaped fries fall through to the boiling area. They're fried to 50% to lock in the quality, flavor, and freshness from the inside out. This step also removes some water and starch from the fries, creating a light crust on them. The oil they're fried in is a mix of canola, corn, soybean, and hydrogenated soybean oils. This blend is healthy because it doesn't contain trans fats or cholesterol. After the fries are half fried, they're taken out with an elevator and set aside to air dry. This usually takes about 5 to 10 minutes. During this time, any extra oil dries up, making the crispy, half-cooked fries ready for packing. The fries that are only half-cooked get frozen super fast in a special freezer tunnel. This keeps their taste and texture just right. Freezing them quickly is important to make sure they all look the same and can be stored without going bad. Potatoes can spoil quickly once they're peeled or cooked. After that, the fries are put in cool trucks or storage areas, all set to be sent off to restaurants. Cutting onions seems like the toughest part of cooking, right? It's the reason half of us are scared to even start cooking. But what if we told you that you could skip that mountainous task entirely? These machines are so efficient that no matter how you place the onion, they'll figure it out, set it right, and then, with the help of a belt that looks like a bunch of molds, make peeling and cutting super easy. First, gadgets that remove the tough outer layer grab onto the onion and peel it away in no time. Look at how cleanly and perfectly peeled these onions are now, all thanks to these fantastic machines. After a manual quality check to ensure no bad onions slip through, they're sent to be cut. This manual check is crucial. If there's a bad one, it can be caught and removed by hand. With incredibly precise cutting, all these onions are then packed and frozen, ready to help you out in the kitchen. If you want to get the job done without even touching the fish, don't worry, these machines will do everything for you. You won't have to touch them at all. These preset units seal a specific amount of fish into packets perfectly. It's rare for these machines to make mistakes. Well, to say they never do would be stretching it. They do make errors, but only at a rate of 0.001%, because they're tested over 100 times before being used in factories. First off, thanks to their excellent eyesight, these machines quickly sort out the bad apples to one side while the good apples gently move along the belt. These good apples are on their way to be turned into apple puree, which is used in a variety of delicious dishes. These machines process a ton of apples into smooth, sweet puree in no time. It's amazing to see apples zip through this process and come out as something that makes our food taste so good. The apple skins are removed and sent to another area, often ending up mixed into fodder at dairy farms. Here we have one of the biggest and most famous automated lines for making pancakes. You'll see everything from the batter being poured to the pancakes being cooked and layered, all done by machines without a hitch. These molds take a ride through an oven where the pancakes are cooked until they're just right, golden and delicious. After cooking, the pancakes are carefully picked up and arranged into neat stacks, ready to be packed and shipped out. Nutella's factory process is the most complicated in the world. With all elements coming together, high-tech machines work together to create the most popular spread in the world. Let's dive deep into how Nutella is made, showcasing the massive machinery used to manufacture the product. To create the world's most beloved hazelnut and cocoa spread, the manufacturing facilities are equipped with advanced machinery, precision-engineered systems, and rigorous quality controls. Each step in the process is optimized for efficiency, consistency, and the highest standards of food safety. In this detailed breakdown, we'll explore how Nutella is made inside a modern factory, from the raw materials to the final product, with a close look at the construction, operation, and technical aspects of the factory's systems and machinery. The process begins with the sourcing of raw ingredients, including hazelnuts, sugar, cocoa powder, palm oil, skim milk powder, and vanillin. These ingredients are delivered to Nutella factories in massive quantities, requiring large-scale handling infrastructure. Hazelnuts, one of the key components of Nutella, are often sourced from Turkey and Italy, two of the largest hazelnut producers in the world. Upon arrival at the factory, hazelnuts are stored in enormous silos or temperature-controlled storage rooms to maintain their freshness. The silos are made of food-grade stainless steel and designed to protect the nuts from humidity and contamination, while allowing for precise dispensing into the production line. The first step in processing the hazelnuts is cleaning. Hazelnuts arrive in bulk shipments, often mixed with debris such as shells, stems, and dirt. To address this, the factory uses a series of cleaning systems that include vibrating screens, air classifiers, and magnetic separators. The vibrating screens shake the nuts to separate them from larger debris, while the air classifiers blow away lightweight impurities like husks and dust. Magnetic separators are also used to detect and remove any metallic particles that might have entered the shipment during harvesting or transport. Once cleaned, the hazelnuts undergo visual inspection using high-speed optical sorting machines equipped with cameras and sensors. These machines identify and remove any defective hazelnuts, such as those with discoloration, cracks, or signs of mold. After cleaning, the hazelnuts move to the roasting stage. Roasting is a crucial step in developing the rich, nutty flavor that characterizes Nutella. In the factory, this is achieved using massive industrial roasting ovens. These ovens are designed with rotating drums or conveyor belts to ensure even roasting. The temperature is carefully controlled, typically ranging between 280 and 320 degrees Fahrenheit, depending on the size and moisture content of the hazelnuts. Sensors monitor the temperature and time to ensure consistency, as over-roasting can lead to bitterness, while under-roasting can result in a lack of flavor. The entire roasting process is automated, and the equipment is designed for continuous operation to handle the high volume of hazelnuts required for production. Once roasted, the hazelnuts are transferred to grinding machines. These machines are equipped with heavy-duty stainless steel blades and rollers that crush the nuts into a fine paste. The grinding process occurs in multiple stages, with each stage further reducing the particle size of the hazelnut paste. In the initial stage, the nuts are coarsely ground into a chunky paste. In the subsequent stages, the paste is refined into a smooth consistency, with particle sizes measuring less than 30 microns. This ultra-fine grinding is essential for achieving Nutella's creamy texture. The equipment used in this process, such as colloid mills and ball mills, is highly specialized and designed to operate under high pressure and at precise speeds. The resulting hazelnut paste is collected in large stainless steel tanks, where it is stored at a controlled temperature to preserve its flavor and consistency. While the hazelnut paste is being prepared, the other ingredients are processed in parallel. Sugar, which provides sweetness to Nutella, is delivered to the factory in bulk containers or tankers. Upon arrival, the sugar is unloaded into silos, equipped with pneumatic conveying systems. These systems use air pressure to transport the sugar from the silos to the milling area, where it is ground into a fine powder. Industrial sugar mills are used for this purpose, and the grinding process ensures that the sugar particles are small enough to dissolve uniformly in the mixture. The factory also incorporates sieving systems to filter out any impurities or oversized sugar particles before they proceed to the blending stage. Cocoa powder, another key ingredient, undergoes a similar process. The cocoa powder is stored in sealed silos to protect it from moisture and contamination. Before being added to the Nutella mixture, the cocoa powder is sifted through vibrating screens to break up clumps and ensure a fine, even consistency. This step is crucial for achieving the smooth texture of the final product, as any clumps could create inconsistencies during blending. Palm oil, which gives Nutella its creamy consistency and prevents separation, is stored in large, temperature-controlled tanks. These tanks are equipped with heating elements to keep the oil in a liquid state, as palm oil tends to solidify at room temperature. The oil is pumped through insulated pipes to the mixing area, where it is carefully measured and added to the blend. The precise control of temperature and flow rate is essential to ensure that the oil integrates smoothly with the other ingredients. Skim milk powder, which adds a subtle dairy flavor and contributes to the creamy texture of Nutella, is stored in sealed containers or silos to prevent exposure to air and moisture. Before being used, the milk powder is sifted and screened to remove any lumps. Factories use advanced pneumatic conveying systems to transport the milk powder from the storage silos to the mixing area, ensuring that the ingredient is handled efficiently and hygienically. The blending process is the heart of Nutella's production, where all the prepared ingredients come together to form the final product. The blending tanks used in Nutella factories are massive, often with capacities of several thousand gallons. These tanks are equipped with high-speed agitators and temperature control systems. The hazelnut paste, sugar powder, cocoa powder, skim milk powder, palm oil, and vanillin are added to the tank in precise proportions, which are controlled by computerized dosing systems. These systems are programmed to weigh and dispense each ingredient accurately, ensuring consistency across batches. During blending, the mixture is heated slightly to help the ingredients combine more effectively. The temperature is carefully monitored, as excessive heat could alter the flavor and texture of the product. The blending tanks are designed to ensure even mixing, with agitators that create a vortex to incorporate all the ingredients thoroughly. The result is a homogeneous mixture with a smooth, creamy consistency. Once the blending process is complete, the mixture undergoes a refining stage. Refining is a critical step that ensures the final product is free of any graininess. The refining process takes place in multi-stage roller mills, which are equipped with heavy-duty steel rollers. These rollers apply immense pressure to the mixture, reducing the particle size of any remaining solids to less than 20 microns. This process not only enhances the texture of Nutella, but also improves its spreadability. The roller mills are fitted with precision sensors that monitor the pressure and temperature during refining, ensuring optimal performance. After refining, the mixture is transferred to the conching stage. Conching is a process borrowed from chocolate manufacturing and involves agitating the mixture in large, heated tanks for several hours. This process helps to further smooth the texture and enhance the flavor of the spread by allowing volatile compounds to evaporate and by evenly distributing the fats and solids. The conching tanks are equipped with paddles or rollers that knead the mixture continuously. The temperature and duration of conching are carefully controlled, as overconching could negatively affect the spread's consistency. The finished Nutella is then pumped into holding tanks, where it is kept at a controlled temperature until it is ready for packaging. These tanks are equipped with agitators to prevent separation and maintain the spread's uniformity. Before the Nutella is packaged, it undergoes a final round of quality control. Samples from each batch are tested for flavor, texture, color, and viscosity. The factory uses advanced laboratory equipment such as viscometers and spectrophotometers to ensure that the product meets the company's stringent standards. Any deviations from the desired specifications are identified and corrected before the product proceeds to the packaging stage. Packaging is the final step in Nutella's production process, and it is carried out with the same level of precision and efficiency as the earlier stages. The spread is pumped from the holding tanks into automated filling machines, which dispense precise amounts of Nutella into jars. The filling machines are equipped with high-speed nozzles that can fill hundreds of jars per minute. Each jar is made from food-grade plastic or glass and arrives at the factory pre-sterilized to ensure hygiene. The jars are sealed with tamper-proof lids, which are applied and tightened using automated capping machines. Once the jars are sealed, they are conveyed to labeling stations, where Nutella's iconic branding is applied. The labels include important information such as the lot number, production date, and expiration date, which are printed using high-speed inkjet or laser printers. After labeling, the jars are inspected by vision systems that check for defects such as misaligned labels or damaged seals. Any defective jars are automatically removed from the production line. The jars are then packed into cardboard cartons using robotic packing systems. These systems are programmed to arrange the jars in specific configurations to maximize space and protect the jars during transportation. The cartons are sealed and stacked onto pallets using robotic palletizers. The pallets are then wrapped in plastic film for stability and loaded onto trucks or shipping containers for distribution. The entire packaging process is designed for high efficiency, with minimal manual intervention and maximum output. Throughout the factory, automation plays a key role in maintaining efficiency and consistency. Programmable logic controllers and supervisory control and data acquisition systems are used to monitor and control every aspect of the production process. These systems provide real-time data on parameters such as temperature, pressure, and flow rates, allowing operators to make adjustments as needed. The factory is also equipped with advanced robotics and machinery that ensure smooth operation, from ingredient handling to final packaging. Hygiene and safety are top priorities in Nutella factories. Production areas are constructed with food-grade stainless steel surfaces and epoxy-coated floors that are easy to clean and sanitize. Air filtration systems maintain a clean environment by preventing airborne contaminants from entering critical zones. Employees follow strict hygiene protocols, including wearing protective clothing and washing their hands regularly. The factory is regularly inspected to ensure compliance with international food safety standards, guaranteeing that every jar of Nutella is safe for consumption. This intricate, highly automated process ensures that Nutella is consistently smooth, flavorful, and delicious, meeting the high expectations of its millions of fans worldwide. Every step, from the handling of raw ingredients to the final packaging, is a testament to the engineering and precision that go into creating this beloved spread. The result is a product that continues to delight consumers, one jar at a time. Peanut butter, a staple spread beloved worldwide for its creamy or crunchy texture, requires a sophisticated and highly organized manufacturing process to meet the demand for consistent quality and flavor. Behind every jar of peanut butter is an intricate factory process that starts with the raw peanuts and ends with precisely packaged jars ready for distribution. Let's take an in-depth look at the factory production process, exploring the machines, systems, and engineering techniques that make it all possible. The process begins with the sourcing of raw peanuts. These peanuts are typically grown in countries like the United States, China, India, and Argentina, which are among the largest producers of peanuts globally. Peanuts are harvested in vast quantities, cleaned and dried at their source before being shipped to peanut butter manufacturing facilities. Factories require a consistent supply of high-quality peanuts, and to ensure that the raw peanuts are often tested upon arrival for size, moisture content, and overall quality. This ensures only the best peanuts are used for processing. Upon arrival at the factory, peanuts are stored in massive silos or bins designed specifically for food products. These silos are constructed from food-grade stainless steel or coated steel to prevent contamination and ensure proper hygiene. Inside the silos, the peanuts are protected from moisture, pests, and temperature fluctuations. These storage systems are equipped with conveyor systems that efficiently transfer peanuts from the silos to the initial cleaning and processing stages. The first step in processing peanuts is cleaning. Even though peanuts are partially cleaned at their source, factories implement a rigorous cleaning process to ensure no foreign materials or impurities remain. Vibrating screens are used to remove debris such as dirt, stones, and small sticks. Air classifiers blow air through the peanuts to remove lighter debris such as peanut skins or husks. Magnets are also employed to extract any metallic impurities. Optical sorting machines equipped with cameras and sensors scan each peanut as it moves along a conveyor belt, automatically removing any defective peanuts, including those with discoloration, mold, or deformities. After the cleaning process, the peanuts proceed to the roasting stage. Roasting is a critical step in peanut butter production, as it develops the rich, nutty flavor that defines the final product. Factories use industrial roasting ovens to roast the peanuts at controlled temperatures. These ovens come in two main types: batch roasters and continuous roasters. Batch roasters are used for smaller production lines, while continuous roasters, which use conveyor belts to move peanuts through a heated chamber, are used for larger scale operations. The temperature in these roasters typically ranges from 300 to 350 degrees Fahrenheit. The roasting process is closely monitored with temperature sensors and automated control systems to ensure the peanuts are roasted evenly. If some peanuts are over-roasted, they can turn bitter, while under-roasted peanuts may lack flavor. The level of roasting can also be adjusted depending on whether the final peanut butter will have a mild or more robust taste. Once roasted, the peanuts are cooled to stop the cooking process. Cooling is achieved by passing the roasted peanuts through chambers with powerful fans or cool air blowers. This step is crucial because it prevents the peanuts from continuing to cook, which could lead to inconsistencies in flavor. Some factories also use a water spray system to rapidly cool the peanuts, though this is less common as it can add moisture to the product. The cooling systems are designed to operate continuously to keep pace with the output of the roasting ovens. With the peanuts roasted and cooled, the next step is to remove their skins and separate the kernels. Skin removal is done using blanching machines. These machines have rotating drums or abrasive rollers that rub the peanuts, causing the thin outer skin to flake off. Some systems use steam blanching, where the peanuts are exposed to high-pressure steam to loosen the skins before mechanical removal. After blanching, the peanuts pass through air classifiers that blow away the loose skins, leaving behind clean peanut kernels. Factories also use gravity separators to sort peanuts by size and density, ensuring that only uniform peanuts proceed to the grinding stage. Before grinding, the peanuts are inspected again for quality. This is done using high-speed optical sorters that ensure any remaining defective peanuts are removed. Factories often have automated weighing and proportioning systems at this stage to determine the exact amount of peanuts needed for each batch. This level of precision is crucial for maintaining consistency in the flavor and texture of the peanut butter. The grinding process is the heart of peanut butter production. The roasted peanuts are fed into industrial grinders, where they are crushed into a fine paste. This process happens in multiple stages, beginning with coarse grinding and followed by finer grinding. The equipment used for this includes hammer mills and roller mills, which are specifically designed to reduce the peanuts into small, uniform particles. In many factories, the particle size is reduced to less than 20 microns, which is smaller than the diameter of a human hair. Achieving such a fine consistency is essential for the creamy texture that many consumers expect from peanut butter. For crunchy peanut butter, the process is slightly different. In these cases, a portion of the peanuts is coarsely ground and set aside before the final blending stage. These larger peanut pieces are later mixed into the smooth paste to create the characteristic crunchy texture. To prevent the peanut butter from separating, stabilizers such as hydrogenated vegetable oils or palm oil are added during the grinding process. These oils help bind the natural peanut oils to the solid peanut particles, ensuring a smooth and stable product that doesn't separate in the jar. Salt and sugar are also added at this stage to enhance the flavor of the peanut butter. Factories use precision dosing systems to measure and add these ingredients in exact proportions, ensuring every batch has the same taste. After grinding, the peanut butter is sent through a mixing stage, where it is further blended in large stainless steel tanks equipped with high-speed agitators. This stage ensures that the stabilizers, salt, and sugar are evenly distributed throughout the peanut butter. These tanks are often heated slightly to keep the peanut butter at the right consistency for mixing. The temperature is carefully controlled, as overheating can alter the flavor or texture of the peanut butter. Once the mixing is complete, the peanut butter undergoes quality control checks. Samples from each batch are tested in an on-site laboratory for flavor, texture, and consistency. Advanced instruments, such as viscometers, are used to measure the viscosity of the peanut butter, ensuring it meets the desired standards. Factories also use particle size analyzers to confirm that the peanut butter's texture is smooth and uniform. These quality checks are critical, as even slight variations can impact the final product's appeal to consumers. The final step in the manufacturing process is packaging. The peanut butter is pumped from the mixing tanks to filling machines, where it is dispensed into jars. These filling machines are capable of handling thousands of jars per hour, ensuring high efficiency. The jars, typically made of food-grade plastic or glass, arrive at the factory pre-cleaned and are sterilized again before filling. The filling nozzles are designed to dispense precise amounts of peanut butter into each jar, ensuring uniform weight and volume. Once the jars are filled, they move to the capping machines, where tamper-proof lids are applied and tightened. After capping, The jars are conveyed to labeling machines, which apply the brand's signature labels, along with lot numbers and expiration dates for traceability. Vision systems inspect each jar to ensure that the labels are correctly applied and that there are no defects in the seals or packaging. The jars are then packed into cardboard boxes using robotic packing systems. These robots are programmed to arrange the jars in specific configurations to optimize space and protect the jars during transportation. The boxes are sealed and stacked onto pallets using automated palletizing systems. Finally, the pallets are wrapped in plastic film for stability and loaded onto trucks or shipping containers for distribution. Throughout the entire production process, automation plays a vital role in maintaining efficiency and consistency. Factories are equipped with programmable logic controllers, PLCs, and supervisory control and data acquisition, SCADA systems, that monitor and control every aspect of production. These systems provide real-time data on parameters such as temperature, pressure, and flow rates, allowing operators to make adjustments as needed. Robotic systems handle many tasks, from sorting and cleaning peanuts to packaging the final product, reducing the need for manual labor and ensuring precision. Hygiene and safety are also top priorities in peanut butter factories. The production areas are constructed with food-grade stainless steel surfaces and epoxy-coated floors that are easy to clean and sanitize. Positive air pressure systems prevent airborne contaminants from entering critical zones, while strict hygiene protocols ensure that employees maintain cleanliness throughout the production process. The entire facility is regularly inspected to comply with international food safety standards, ensuring that every jar of peanut butter is safe for consumption. Peanut butter production is a complex and highly technical process that relies on advanced machinery, precise engineering, and rigorous quality control. From the cleaning and roasting of peanuts to the grinding, mixing, and packaging of the final product, every step is designed to create a spread that is smooth, flavorful, and consistent. Factories operate with remarkable efficiency, producing thousands of jars per day to meet the global demand for this versatile and beloved product. Strawberry jam production is a fascinating and highly engineered process that combines precision machinery with time-tested techniques to create a smooth, fruity spread. At the core of this process are high-quality strawberries, sugar, pectin, and citric acid, all carefully handled and processed to achieve the perfect consistency and flavor. Inside a modern jam factory, every step is optimized for efficiency, consistency, and food safety. The process begins with the selection and delivery of fresh or frozen strawberries. Factories typically source strawberries from local farms or large-scale suppliers. Frozen strawberries are often preferred for large-scale production because they are preserved at peak ripeness, ensuring consistent flavor year-round. The strawberries arrive in bulk containers and are stored in cold rooms or freezers to maintain their quality until processing begins. Before entering the production line, the fruit undergoes a thorough cleaning process. This includes washing the strawberries in large tanks filled with filtered water, where gentle agitation removes dirt, debris, and any residual pesticides. Once cleaned, the strawberries pass through optical sorting machines. These machines use cameras and sensors to identify and remove defective or discolored fruit. Advanced systems can even detect minute imperfections, ensuring that only the highest quality strawberries make it into the jam. After sorting, the strawberries are sent to cutting or mashing machines, depending on the desired jam texture. For chunkier jams, strawberries are coarsely chopped, while for smooth spreads, they are mashed or pureed into a uniform consistency. The fruit then enters large stainless steel cooking kettles or continuous cooking systems. In these vessels, the strawberries are combined with sugar, which not only sweetens the jam, but also acts as a natural preservative. The sugar is added using automated dosing systems that measure precise quantities to ensure consistent flavor. Pectin, a natural thickening agent derived from fruit, is added to help the jam set. Citric acid is also incorporated to balance the sweetness and enhance the fruit's natural flavor. The mixture is slowly heated, with temperatures reaching up to 220 degrees Fahrenheit to activate the pectin and achieve the ideal gel-like consistency. During cooking, the jam undergoes constant agitation to prevent scorching and ensure even heating. Steam-jacketed kettles or vacuum cookers are often used, as they allow for rapid and uniform heating. Modern vacuum systems are particularly advantageous because they enable cooking at lower temperatures, preserving the fresh flavor and bright color of the strawberries. Throughout the cooking process, sensors monitor the temperature, pH levels, and viscosity of the jam, ensuring that the final product meets strict quality standards. Once the jam reaches the desired consistency, it is pumped through a series of filters to remove any seeds or large pieces if a smoother texture is desired. The finished jam is then transferred to filling machines. These machines dispense precise amounts of jam into sterilized glass jars or plastic containers. The jars are immediately sealed with tamper-proof lids to maintain freshness and prevent contamination. After sealing, the jars are passed through pasteurization tunnels, where they are briefly heated to destroy any remaining microorganisms. Finally, the jars are labeled, inspected, and packed into cartons using robotic packaging systems. The entire process is highly automated, ensuring efficiency and consistent quality, from the arrival of fresh strawberries to the delivery of jars to store shelves. This seamless blend of traditional cooking techniques and advanced technology ensures that every jar of strawberry jam is rich in flavor, perfectly textured, and safe for consumers to enjoy.